Imagine a timeless void, a vast quiet that stretches infinitely. In this primordial silence, there was nothing, no light, no sound, not even time itself. It was like an endless night, a deep and silent slumber of the universe. Then, in an instant, too small to imagine, that quiet was transformed. From a delicate spark, the universe breathed its first breath. Space and time emerged together, woven by the flicker of creation. The very fabric of reality stretched outward, as if a dark canvas was being revealed stroke by stroke. At first, this expansion was wildly fast, a fleeting moment known to dreamers and physicists as cosmic inflation. For a blink in eternity, the universe grew colossal, from a subatomic sliver to a vast expanse beyond comprehension. It was as if the cosmos took a sudden, giant breath, stretching space itself like a balloon being inflated. In that exquisite moment, the entire universe was smaller than a single marble. It was a dense, glowing fog of energy and particles, hot enough to outshine any star, hidden in its radiant mist. As the cosmic fog expanded, it slowly cooled, like embers of a gentle fire fading into twilight. With each passing moment, the universe became a quieter place. Time stretched out, and particles slowed their frantic dance. Light still could not travel far, scattering like whispers in a deep, dark forest. But the seed of an idea, that one day there would be galaxies, stars, and planets, had begun to form in that darkness. In that cooling cosmos, tiny fluctuations grew into patterns that would one day become galaxies. In the simplest terms, everything we know was encoded in those first moments. The echo of that initial breath left subtle imprints across space, a cosmic blueprint for all that would follow. The air of nothingness had become a canvas of potential, strewn with the seeds of galaxies and stars. Even in the quiet aftermath of that tremendous burst, the universe held mysteries yet to be told, as it gently unfolded like a story waiting to be read beneath the starlight. No one was there to witness that first instant, and yet everything began at that tiny point. It is a mystery whispered in the quiet corners of physics. How could something come from nothing at all? Some say that even empty space is alive with possibility. Deep within the very fabric of emptiness, tiny fluctuations can spark reality into being. Perhaps the universe sprang to life from the quantum foam, or some hidden well of energy in the void. In those earliest moments, time itself was brand new. Before the first breath of the universe, there was no clock ticking, no before or after. It was as if creation itself invented time as it expanded. Asking what happened before the beginning may not even make sense, because there was no before in the way we understand it. The beginning and time were born together in that gentle explosion. Physicists call this event the Big Bang, though there was no bang like an explosion, nor a space into which it expanded. Imagine instead a cosmos, lighting up like a sparkler in every direction at once. All of space was filled with that same spark, which then settled into a warm glow. In a way, the universe is less like an explosion at a point, and more like the steady unfolding of a flower, gentle, organic, mysterious. In the quiet, empty expanse of those days, the universe carried on a conversation in whispers of light. Eventually, billions of years later, that conversation would still be audible to us. Across the eons, the afterglow of that first moment cooled but never fully went away. Every direction we look, we still see its gentle warmth, an echo of creation's first breath, whispering to us through the cosmic ages. Within minutes of its birth, the universe was a deep, swirling furnace. Protons and neutrons crashed together in the heat, fusing into the very first atomic nuclei. Hydrogen and helium, the simplest atoms, were born in that initial blaze. It was the universe's first alchemy, quietly forging the basic ingredients of stars, planets, and life. Yet this process soon ended, and the cosmos entered a long, cool waiting period. Over hundreds of thousands of years, the universe grew ever quieter. As it expanded and cooled, charged particles eventually combined into neutral atoms. Suddenly, space became transparent. For the first time, the light from that primeval fire could travel freely across the cosmos. That glow filled every corner of space, a faint warmth that still lingers today. It is the afterglow of the beginning, a silent, gentle hum that carries the memory of that very first moment. So now the stage is set. The universe rests quietly under the pale glow of its own birth. All is calm in that gentle light, as if the cosmos is taking a long, deep breath. Even the stars have not yet kindled their flames. Everything is still, waiting. In this tranquil abyss, the next marvel is poised to begin. Even after creation's first great exhale, the universe left itself a faint trail. Today, we call these the silent echoes of creation. They are subtle signals carried across the cosmos, whispering tales of that very first moment. Though the universe has cooled and quieted, it has not forgotten its past. In every direction we look, there is a soft murmur of what happened when space was newborn, a hush that tells of early light and energy still traveling through time. Imagine looking at the sky, not with your eyes, but with special instruments attuned to microwaves. When scientists do this, they discover a gentle glow covering the entire sky. It is the cooled remnant of the universe's first light, now stretched into radio waves. To our eyes, the sky is dark, but this afterglow fills the heavens with a subtle warmth, just a few degrees above absolute zero, as if the cosmos were wrapped in a faint orange glow from the dawn of time. This cosmic afterglow is nearly uniform in every direction. No matter where we look, the whispering light is there, like a soft blanket covering everything. But it is not perfectly smooth. With sensitive instruments, we find tiny temperature differences, slight hot and cold spots in this glow. These minute ripples are not random. They are the frozen imprints of sound waves in the early universe's plasma. They mark the places where gravity would later pull matter together to form galaxies and stars. In a sense, this afterglow is the universe's baby picture, an image of the cosmos when it was just a year or so old. By cosmic standards, it's really the world's oldest snapshot, taken just 380,000 years after the beginning. It tells us that the infant universe was an incredibly hot, dense soup. Over time, it has cooled to a quiet murmur. The patterns we see in it, faint rings and spots, reveal how matter was spread out and how it clumped together. It is as if we are studying an old photograph of a community before its buildings have yet been constructed. This is the ultimate in silence. There is no sound in space. But if the universe had a memory, it would be in this microwave background. With radio telescopes tuned just right, it sings its ancient lullaby. We might think of it as the cosmic microwave background, though in this gentle story, it feels more like a distant hum brushing the fabric of space. Could there be other echoes hiding in the void? Perhaps deep within the silence, ripples in the very shape of space-time still glide through us. Gravitational waves from the cosmic birth would be the subtlest of whispers, and scientists on Earth search for them too. They would be like the silent footsteps of creation, barely detectable but ever present if we learn to listen with sensitive instruments and open minds. In our own time, telescopes have learned to listen to this cosmic whisper. Satellites and observatories mapping the heavens have painted a detailed map of the afterglow. They find that its minute fluctuations form a delicate pattern across the sky. Each tiny spot marks where matter was a little more or less dense in the past. These patterns are like ancient footprints, a cosmic fingerprint left by the earliest moments. By tracing these ancient footprints, scientists have pieced together the story of the universe. They learned that nearly every atom around us was shaped by these early imprints. The clumps and voids hinted at the distribution of galaxies we see today. In this way, the silent echoes guide us. They tell us about the content of the cosmos, the mix of ordinary matter, invisible dark matter, and the mysterious energy pushing it apart. All of this information rides in that gentle glow. Beyond light and gravity, there may be other cosmic whispers we have not yet fully heard. For example, space should be filled with relic neutrinos from the first second of the universe. These tiny particles zipped through the cosmos long ago, barely interacting with anything, but they too carry the memory of creation. If we could build detectors sensitive enough, we might one day listen to that silent background of neutrinos too. Everything in the universe, from distant galaxies to each grain of sand on Earth, is connected by the echoes of those first moments. When we gaze at the night sky in complete darkness, we are bathed in the faint glow of history itself. The sky's silence is an ocean filled with whispers. From any place in this vast universe, if one were to stand and listen with the right instruments, the message would be the same. The story of creation, unfolding softly across time. For many millions of years after that first glow, the universe lay dark and quiet. It was a silent darkness filled with potential. The faint murmur of creation's afterglow was all around, wrapping the cosmos like a soft blanket. But in that calm, the universe was quietly preparing for its next act. Soon, that silence would finally be broken. After a long, dark slumber, the universe awoke with the faintest glimmers of light. In the emptiness left by the echoes, tiny pockets of gas began to gather under gravity's gentle pull. Slowly, under that unseen force, the cold hydrogen and helium coalesced, condensing into dense clouds. In these clouds, the universe's first stars found their birth. Each cloud was a cradle of creation, birthing titanic furnaces of light in the still night sky. These first stars were unlike any we see nearby today. Formed from pure hydrogen and helium, they were giants, hundreds of times more massive than the sun. Their light was fierce and blue-white, and they burned with a brilliance that could outshine all others. Yet, unlike later stars, they were as ephemeral as fireflies. In a few million years, each star would exhaust its fuel and die in a blaze of glory, scattering its enriched ashes into space. As each first star lived its brief life, it transformed its surroundings. The powerful ultraviolet light from these newborn stars began to push away the cosmic fog around them. The darkness that filled the universe gradually lifted in local regions. The stars turned patches of space from opaque to transparent, one by one. Around every ancient flame, hydrogen gas became ionized and clear, letting starlight stream freely. It was the true cosmic dawn, the moment when darkness finally gave way to light. With time, more stars formed, not in isolation, but together in groups. These early assemblies of stars are what we call the first galaxies. They were still small by our modern standards, but they glowed like clusters of distant lanterns in the dark. Slowly, these fledgling galaxies merged and grew, drawn by gravity. Each union formed a brighter, larger island of light. In this way, the starry islands grew, lighting up the cosmic ocean bit by bit. The very first supernovae were triumphant fireworks marking the end of these massive stars. When a giant star died, it exploded, sending shockwaves through the gas around it. These explosions forged the universe's first heavy elements, creating carbon, oxygen, and iron. These elements were the building blocks of planets and life. In that way, even the death of the first stars was part of a grand creation story. The ashes of these stellar giants would one day become part of worlds yet to form. As more stars and galaxies ignited, the universe became a brighter place. The combined glow of countless early stars began to light up the cosmos. If an observer could see back then, the night sky would have been gradually suffused with light, like the sky before dawn. The darkness was retreating. From deep blackness, a faint glow rose across the heavens, as if a gentle sunrise was coming to the universe itself. This era of the first light is often called the cosmic dawn. And indeed, for our small galaxy, it was a dawn of discovery. For us, thousands of generations later, to witness. Those first stars and galaxies set the stage for everything that followed. They seeded the cosmos with the complexity needed for planets and ultimately life. Looking at the night sky now, we see the outcome of that cosmic dawn. Stars sprinkled across the heavens are distant echoes of those long-vanished pioneers, each light a fragment of that ancient sunrise. It took perhaps 100 million years after the Big Bang for the first true lights to come on. Think of it as a cosmic night giving way to dawn. For that time, only the faint afterglow and the cold of space existed. But gradually, the universe's skies filled with pinpricks of light that grew ever brighter. Each new star was a spark in the darkness, spreading a subtle daylight. As clusters of these first lights joined together, entire regions were bathed in the warm glow of dawn. We can imagine standing on a silent world, feeling the chill of endless night, and then seeing the first points of light kindle one by one on the horizon. The dark universe became a lively tapestry. From the ashes of long-dead stars, new elements flowed into the void. The very act of starbirth forged new chemistry. Suddenly, the universe was no longer just hydrogen and helium, but was enriched with carbon, oxygen, and other elements that allow planets, and perhaps life, to exist. These stories of first light are the prologue to our cosmic history. Under the light of the cosmic dawn, the ingredients for galaxies, planets, and eventually life were assembled. The first stars painted the sky, but their influence went far beyond light. They shaped everything that followed. Now, billions of years later, when we look at the heavens on a dark night, we are gazing at the echoes of that dawn. Each star we see is a descendant of those first flames, a symbol of the universe's continuity and the gentle passage of time. As the first stars gathered into fledgling galaxies, the universe took on the look of a cosmic ocean dotted with islands of light. Each galaxy is a vast city of stars, dust, and gas, bound together by gravity. Imagine an endless sea of night, and floating on it are countless bright archipelagos. Our own galaxy, called the Milky Way, is just one of these islands. From our island's vantage point, we can see our closest neighbours, the faint smudge of Andromeda and the companions of the Milky Way on the horizon. Each of these galactic islands contains hundreds of billions of stars, swirling in slow cosmic dances. Many are graceful spirals with curving arms, like whirlpools shining in the dark. Others are vast, featureless ellipses, glowing bubbles of stars, or irregular shapes that look like splashes of light. Yet all of them glow with starshine. Within every island, there are places of birth and death, nursery clouds creating new suns, and ancient stars burning out quietly. They hold their own secrets and dramas, unknown to us, but quietly unfolding. On those distant shores, in those far-off galaxies, star systems orbit their centers quietly. Some of those stars may have planets, not unlike Earth. In each galaxy island, unimaginable stories unfold. Worlds turning under alien skies, light from foreign suns rising and setting, and the ballet of orbits continuing in the darkness. All of this happens on such a vast scale that even a galaxy feels small. It is but an island in the grand cosmic sea. Just as islands in an ocean sometimes cluster into archipelagos, galaxies also gather into families and clusters. Our Milky Way belongs to the local group, a small archipelago of a few dozen galaxies drifting together. Nearby, in a vast celestial neighbourhood, lies the Virgo cluster, a bustling city of thousands of galaxies. Each group or cluster is a constellation of islands, held together by gravity, forming neighbourhoods in the cosmic ocean. Yet even these clusters are still just beads on the strands of a larger structure. Between these galaxies, space may appear empty, but it is filled with traces of gas, dust, and mysterious dark matter. Each island is actually surrounded by a ghostly halo of dark matter, an invisible ocean beneath its shining surface. We cannot see this dark matter with our eyes, but its gravity shapes the island's fates, guiding them toward each other. Streams of gas sometimes flow between galaxies, like rivers nourishing fertile shores. In this way, the island universes drift, anchored by unseen tethers and currents, silently moving through the cosmic sea. As we look out into the night, we see the Milky Way's bright band of stars. But beyond that, when we train powerful telescopes on the sky, we glimpse an infinity of galaxies. Even as our senses tell us the night is dark, the truth is that billions of lights shine beyond our reach. Each is a distant island, and the light of those islands is our message from the deep. They carry tales of ancient starfires and cosmic journeys across empty space. Each tiny point of light reminds us how vast the cosmos is, and how many fellow islands there are in this ocean of night. On the largest scales, these island galaxies form great patterns, clustering and weaving. But each one is a world unto itself. We wander on one such island, listening and looking out into the vast ocean. From our home in the Milky Way, we set sail on a journey of understanding, dreaming of the stars of faraway lands. Each galaxy we see reminds us how small we are, and yet how connected, all part of this grand cosmic archipelago, adrift in the darkness. Galaxies do not exist forever in isolation. Over cosmic time, they drift through space and sometimes meet. Imagine two ocean islands slowly approaching until they merge into one. Our own Milky Way will one day collide with the Andromeda Galaxy, combining into a single, larger island of stars. These galactic mergers can ignite bursts of new stars and reshape the island's forms. In the distance, billions of galaxies are likewise drifting, merging, and evolving as the cosmic sea flows on. Astronomers have peered deep into space and found that for every speck of light we see in the sky, there are thousands more far beyond. In tiny telescopic snapshots, they capture thousands of distant galaxies, each a faint island. This sight humbles the mind. Each speck in those images is a galaxy much like our own, with its own stars and planets. The sheer number of these islands reminds us that we are part of something vast and mysterious. Despite the vastness, the island universes are connected by the same forces that govern us at home. Gravity pulls them along, guiding their paths through space. Streams of gas flow between galaxies, sometimes like invisible rivers, nourishing them. In a poetic way, these island universes share a fate, part of the same cosmic archipelago, drifting through the night. When we look out and see a galaxy, we see not only its light, but a distant world, whole worlds beyond imagining. Beyond the islands of galaxies lies an even grander pattern, an enormous cosmic web. If galaxies are islands, then these islands themselves are strung along invisible threads in space. This web is woven from the gravitational pull of dark matter, forming filaments and walls that crisscross the universe. On the largest scales, the cosmos looks like delicate lace or a vast spider's web, with galaxies tracing out its silvery strands. In this cosmic tapestry, clusters of galaxies sit at the intersections, like knots in the fabric. They are giant metropolises of hundreds or thousands of galaxies. From each city, thin lines of galaxies extend outward, linking it to its neighbours. Between these filaments are immense voids, cosmic caverns almost empty of matter. The contrast is dramatic. Dense threads glitter with galaxies, while the voids are deep, dark and quiet, nearly empty space. The cosmic web was born from the afterglow we spoke of earlier. The tiny fluctuations in that first light grew over billions of years, guided by gravity. Dark matter, invisible and mysterious, served as the scaffold for this structure. We cannot see dark matter directly, but we trace it by seeing where galaxies lie. Wherever we find a galaxy, there is dark matter holding it there, forming part of the web. In this way, the silent pull of invisible matter has woven a cosmic net. We ourselves are participants in this web. The Milky Way is part of a thread called the Laniakea supercluster, a vast home that connects us to our galactic neighbours. Through our telescopes, we map not only nearby galaxies, but the filaments connecting them. It's as if we see a map of a great continent, every star and galaxy placed along ridges and streams. The realization is humbling. Our galaxy, our Earth, is part of a structure so immense it spans hundreds of millions of light years. Astronomers have mapped this giant web by surveying the positions of millions of galaxies. From these surveys emerges a grand design, clusters linked by filaments and framed by voids. It's like seeing a snapshot of lightning across the sky. the luminescent network of our cosmic home. Within these filaments, even the tenuous gas glows faintly in X-ray light, a ghostly sheen from the billions of particles stretched between galaxies. The threads of the cosmic web are the routes along which matter flows. In the early universe, gravity pulled matter into these filaments, and over eons, galaxies formed where the threads crossed. Gas streamed along them into the forming galaxies, providing fuel for new stars. Even now, galaxy clusters still grow by pulling in smaller groups along these filaments, like tributaries feeding into a river. Between the threads lie huge voids, cosmic deserts almost empty of matter. These voids are enormous, spanning hundreds of millions of light years. In a void, a vast volume of space can be nearly empty of galaxies, like a great desert. The difference between a filament and a void is stark. The filaments are vibrant with galaxies, light, and activity, while the voids are quiet backwaters where only a handful of lonely galaxies exist. This contrast is part of the beauty of the web. On the largest scales, the cosmic web is still evolving. The expansion of the universe is stretching the web, making the voids larger and the filaments thinner. Over billions more years, the islands and threads will drift further apart, and the darkness will grow. Eventually, galaxies may become isolated islands in an ever-expanding sea. But for now, we float in the midst of this grand web, connected by invisible ties to the distant reaches of the cosmos. In the quiet night, when we gaze at the sky, we are looking into the threads of this immense tapestry. Perhaps one day, humans might drift among these filaments, traveling from one galaxy to another. For now, though, we remain on our single island, aware of the cosmic loom around us. The universe is a tapestry spun from the fabric of space and time, and as we ponder its web, we realize how beautifully our island is connected to the universe at large. In the silent depths of the cosmos, there are places where light itself sleeps, places where the radiance of a billion stars could be swallowed whole and never escape. In these strange abysses of gravity, night is eternal. Not even a single ray of starlight can break free to whisper its story. It is here, in the hearts of these cosmic voids, that we find one of the universe's deepest mysteries, the black hole. Black holes are regions of unfathomable darkness. They begin as giant stars, burning brightly for millions of years, until their fuel is spent. When a massive star reaches its life's final act, its core collapses under its own immense weight. In a cosmic instant, the star's heart implodes, and all its mass is crushed into an incredibly small space. The star's outer layers erupt outward in a brilliant supernova, but the core continues to fall inward, creating a gravitational trap so intense that nothing can climb out, not even light. Imagine a boundary surrounding this dark pit, a threshold of no return. Scientists call it the event horizon, the edge of the black hole's shadow. Crossing this boundary is like stepping over a cliff in space and time. Once you pass that invisible line, the pull of gravity becomes irresistible. Anything that strays too close, a drifting star, a cloud of gas, a wandering spacecraft, will tumble inwards, caught forever in the black hole's embrace. From our vantage outside, we would never see it emerge again. Approaching a black hole is like approaching a deep well in the fabric of the universe. Space itself bends inward, funneling everything down toward the center. If you could watch an object falling towards the hole, you would see something astonishing. As it nears the event horizon, the object appears to slow down. Its light stretches to redder and redder hues, fading from sight, as if time itself were coming to a stop. In reality, the object continues its fall, but from outside, it seems frozen at the edge, taking an eternity to disappear. Time and space perform a slow, eerie dance near a black hole's boundary. And what lies inside, past that silent threshold where our sight cannot follow? No one knows for certain. At the heart of the black hole, all our familiar understanding of physics falters. We speak of a singularity, a single point of infinite density where the mass of the collapsed star is concentrated. It is a concept as hard to grasp as the notion of infinity itself. In that tiny, mysterious heart, space and time might end as we know them. Some have wondered if it could be a doorway, perhaps to another place, another universe entirely, or simply a trap from which nothing ever returns. For now, it remains a realm beyond our vision, a secret kept in perpetual night. In the darkness around a black hole's mouth, there is often a frantic display of light before the eternal calm. As matter spirals inwards, gas and dust from nearby stars drawn inexorably by gravity, it whips around the black hole in a glowing disk. Friction heats the material to searing temperatures, making it shine brilliantly in X-rays and visible light. For a moment, the darkness is wreathed in a halo of radiant fire. But this light is living on borrowed time. It circles, edges closer, and finally plunges past the horizon, vanishing from the observable universe. It is the last cry of matter falling into oblivion. Despite their name, black holes can be some of the most energetic objects in the cosmos. When they feed on infalling matter, they can burp out great jets of energy. Magnetic forces channel some of the hot, swirling gas into beams that shoot out from the poles of the black hole, piercing into space for thousands of light years. These jets are like cosmic lighthouses, announcing the presence of a hungry black hole at the center of a distant galaxy. Yet the very engine driving that brilliance is hidden from view, the central darkness where light has gone to rest. Not all black holes dine lavishly, however. Some are quiet, starved of nearby fuel and virtually invisible. They drift through the galaxy like silent phantoms. Unless a black hole is actively consuming matter, it blends perfectly into the dark backdrop of space. A rogue black hole, one that has been flung away from its home or left wandering after the chaos of galaxies colliding, could pass right by us, and we might only know it by the subtle tug it exerts on nearby stars or clouds. It is a darkness so complete that only its gravity betrays its presence. The concept of a place where light is trapped challenged our imagination for centuries. Black holes were once purely theoretical, products of equations and thought experiments. Even Einstein, whose theories predicted such objects, found them difficult to accept at first. They seemed like absurd, almost paradoxical places, ideas that strained the limits of what nature would allow. How could anything be so dense and powerful that it swallows light itself? It wasn't until the late 20th century that astronomers began to find indirect evidence that black holes truly exist. They saw stars whipping around unseen points, moving so fast that only an enormous hidden mass could be holding them in orbit. They detected mysterious X-ray flares from what looked like empty darkness, the signature of matter being torn apart near an invisible gravitational monster. Piece by piece, the evidence mounted, and the once hypothetical black hole became accepted as a very real part of the cosmic menagerie. And then, the once invisible was finally unveiled. In recent years, humanity managed to capture an image of a black hole's shadow. Using radio telescopes spread across the Earth, Scientists formed an array the size of our planet to peer into the heart of a distant galaxy. What they saw looked like a fiery ring in the darkness, a glowing donut of light surrounding a circular void. That glowing ring was the hot gas at the brink of the event horizon, and the void at its center was the silhouette of the black hole itself, where light had truly gone to sleep. For the first time, we saw the face of one of these cosmic abysses, and it was both humbling and breathtaking. This historic glimpse confirmed what our minds had long imagined. The shadow of a giant black hole, billions of times more massive than our sun, etched against the glowing backdrop of its own fury. It was as if the universe allowed us a tiny peek into one of its darkest secrets. We gazed at the image of that gentle, dark giant, a behemoth anchoring the heart of a galaxy, and we understood a little more about where light sleeps. Black holes come in different sizes. Some are the remnants of stars, holding a few times the mass of our sun, yet compressed into a sphere only a few kilometers across, an infinitesimal pinprick on the cosmic scale. Others are incomprehensibly large, giants that anchor the centers of galaxies. At the core of our own Milky Way lies such a supermassive black hole, as heavy as 4 million suns put together. For now, it slumbers quietly, occasionally nibbling on stray clouds of gas. But when galaxies collide and pour new fuel into their centers, these sleeping giants can awaken, devouring matter and blazing forth as quasars, brilliant beacons that can be seen across the universe, powered by the gravity of darkness. The presence of these supermassive black holes at galactic centers is another mystery. How did they grow so huge? Were they born in the young universe as smaller seeds that rapidly swelled, merging with others and consuming vast amounts of gas? Or did they start out truly colossal from the beginning, formed by mechanisms we have yet to discover? As we sift through the light of the farthest galaxies with our most sensitive instruments, we occasionally find quasars shining from the dawn of time, already harboring black holes 1 billion times the mass of the sun when the universe was in its infancy. How such massive objects assembled so quickly remains an enigma that astronomers are still trying to unravel. In the vicinity of a black hole, gravity is so intense that it bends the path of light from objects behind it. If a black hole drifts in front of a field of stars, it can distort their light like a funhouse mirror, magnifying and warping the starry background. We call these effects gravitational lensing. The black hole acts like a lens of pure gravity instead of glass. Under just the right conditions, the bending light can produce a halo, or even multiple images of a single distant galaxy, like ghostly reflections around the darkness. By observing such oddities, we detect the presence of the otherwise invisible, reading the curves of space as it warps around an unseen mass. What if someone were to journey into a black hole? It is a question that tempts the imagination. For a traveler falling past the event horizon, there would be no dramatic flash or sudden stop at that boundary. They would drift in, feeling nothing unusual at the moment of crossing. But as they continued deeper, gravity would increase ferociously. If they fell feet first, the pull on their feet would become immensely stronger than on their head, stretching them thin, a fate scientists grimly nickname spaghettification. Long before reaching the central singularity, any traveler, or even a sturdy spacecraft, would be torn atom from atom, drawn out into a strand of matter by the tidal forces. From the traveler's own perspective, the fall might feel as if it happens in a finite span of time. but to an outside observer watching from afar. That traveller would never be seen crossing the horizon. They would appear to slow and fade, never quite vanishing, as if time itself had paused at the edge of the abyss. Even if falling in is a one-way journey, black holes aren't completely invulnerable or eternal. In theory, they can lose energy very slowly through what is known as Hawking radiation, a faint whisper of particles stealing away a little of the black hole's mass over time. For a black hole, the mass of a typical star, this evaporation would take an inconceivably long span, far longer than the current age of the universe. All the black holes we know are effectively immortal from our perspective, holding their captive light and secrets for eons to come. But the idea that they could eventually evaporate, that even these dark giants might one day dissolve into a drizzle of energy, adds another layer to their mystery. Even the darkest void may not last forever. Black holes might seem like cosmic destroyers, and in a sense they are, but they also play a creative role in the universe. Their gravity stirs the stars in galaxies, and their violent outbursts can trigger the birth of new stars by compressing clouds of gas. Their jets and winds spread energy and heavy elements across space, seeding future cosmic generations. They are woven into the story of how galaxies grow and change. In a way, they are the yin to the yang of creation, objects of extreme destruction that paradoxically help shape the cosmos. Contemplating a black hole can feel like staring into a bottomless well of mystery. It reminds us of the profound limits of our knowledge and the vast extremes that nature allows. Here is a place where the normal rules of reality break down under forces we can barely imagine. It is a sphere of darkness, a pit in space-time itself, where light rests and time nearly stands still. In our minds, we stand at the precipice of that abyss, looking in with wonder and humility. We send our thoughts into places our bodies can never venture, trying to fathom what lies beyond that veil of darkness. In the stillness of a black hole's shadow, one can almost sense the cosmos holding its breath. It is a silence not of nothingness, but of secrets beyond our grasp. These gravitational abysses are scattered throughout the universe like silent challenges to the light. And yet, even in their triumph over light, black holes share their presence in subtle ways. Through the dance of stars around an unseen mass, through the gentle bending of light from faraway suns, through the ripples in space-time when they collide, and through the faint whisper they may emit over eons. As we drift away from one of these lightless sentinels, we carry with us more questions than answers. The image of a starry whirlpool frozen at the edge of darkness lingers in our minds. But the universe holds many kinds of mysteries, not all as stark as a black hole's shadow. Some are diffuse, hidden in plain sight, like ghosts that pervade the cosmos without ever being seen directly. We leave behind the realm of sleeping light and venture onward in search of those invisible presences that silently shape the fate of galaxies. An invisible presence does indeed haunt the galaxies. As we drift among the swirling stars of a galaxy, we find that something unseen is gently tugging on them. The stars in a galactic disk, especially those at the fringes far from the center, are moving far faster than they should be if only visible matter existed. It is as though an extra hidden gravity is pulling on them, preventing them from flying away into space. This mysterious influence is like a ghost. We cannot see it, we cannot touch it, but we feel its effect. It holds the galaxies together in a silent, unseen embrace. Astronomers first noticed this cosmic discrepancy nearly a century ago. In distant clusters of galaxies, they observed galaxies moving so rapidly that, by all rights, the cluster should have flown apart. There simply wasn't enough visible mass, not enough stars or hot gas, to hold those galaxies together with gravity. Something else was there, adding extra gravity to the cluster. They called it dark matter, a poetic way of saying, we don't know what this mass is, only that it does not shine or interact with light. Dark matter lives up to its name. It emits no light, no heat, no radiation that we can directly detect. If we look for it with telescopes, we see nothing. It is completely invisible, like a ghost wandering through a brightly lit room unseen. Yet it outweighs the visible stars and planets many times over. In a typical galaxy, there may be 5 or 10 times more mass in dark matter than in all the normal matter we can see. In fact, most of the matter in the entire universe might be this dark, hidden kind. The glittering galaxies, the glowing nebulae, the vast clouds of gas, all the things that light up the cosmos, are merely the tip of an iceberg. The bulk of the iceberg lies beneath the cosmic ocean, unseen but immensely influential. To picture dark matter, imagine each galaxy is enveloped in a great transparent sphere, a halo much larger than the visible galaxy itself. The stars we see are like fireflies clustered at the center of a vast, invisible cloud. This ghostly halo extends far beyond the edge of the starlight, and it is full of mass we cannot see. When our Milky Way galaxy spins, it is this massive halo that gravitationally anchors the outlying stars, keeping them in their orbits. Without the dark halo, the outer stars would drift away into the void. Each galaxy moves within its own hidden cocoon of dark matter, like an island surrounded by an invisible sea that adds its gravitational pull to the island's mass. Dark matter doesn't gather in neat, luminous objects like stars. Instead, it drifts through space in enormous, diffuse clouds. Across the cosmos, these clouds have shaped themselves into a vast cosmic web. Where dark matter's gravity drew matter together, galaxies and clusters of galaxies formed like bright dew on a spider's web of invisible silk. We see the pattern of that web indirectly. Colossal clusters connected by filaments of galaxies, surrounding huge voids where relatively little matter resides. Computer simulations of the universe show this web-like structure emerging over billions of years. And to match what we observe, the presence of dark matter is essential. It is as though dark matter provided the scaffold on which the visible cosmos was built, a hidden framework guiding the growth of galaxies. Sometimes, dark matter's influence becomes visible in a spectacular way. Imagine a massive cluster of galaxies, overflowing with dark matter, sitting in front of even more distant galaxies. The gravity of the cluster, much of it from the unseen mass, bends and distorts the light from the background galaxies. When we observe such a scene with telescopes, we might see those distant galaxies smeared into arcs, or even appearing multiple times in a funhouse mirror illusion of light. These are called gravitational lenses, and they reveal the otherwise invisible. By mapping these distorted arcs of light, astronomers can deduce where the mass lies in the intervening cluster. And often they find the majority of it doesn't correspond to any visible material. The lensed shapes tell us the ghost is really there, its gravity betraying its presence. In one extraordinary cosmic event, astronomers witnessed what happens when clusters of galaxies and their dark halos collide. One system, famously known as the Bullet Cluster, provided a dramatic demonstration. Two massive galaxy clusters crashed through each other at tremendous speeds. The hot gas within them, which we can see in X-rays, slammed together and slowed down, like two clouds of smoke colliding head-on. But the dark matter in each cluster, being invisible and non-interacting, simply sailed through the collision untouched, ghostly passengers continuing on their way. When scientists mapped the mass in this collision by observing how it bent background light, they found that most of the mass had moved ahead of the visible gas clouds. It was as if the tangible matter had been left behind, while the ghostly matter passed straight through. This was a striking confirmation that dark matter is real and distinct, behaving exactly like a silent cosmic ghost, noticeable only by the gravitational footprints it leaves behind. What could this dark matter be? That question remains one of the greatest unsolved puzzles of modern astronomy. We know what it is not. It is not made of the familiar atoms that build our bodies, our planet, and the stars. It isn't ordinary matter that simply fails to shine. Even clouds of cold gas can be detected by their faint glow, or by how they block light. Dark matter, on the other hand, doesn't emit or block light at all. It passes through regular matter, almost as if neither existed for the other. It might consist of exotic particles, species of matter that flooded the young universe long before stars and galaxies existed. These particles could be all around us, streaming through the room you sit in and through your very body at this moment, like an invisible wind. If so, they barely interact with the atoms we are made of. They are like shadows that have mass, but no substance we can touch. One known ghostly particle in nature is the neutrino, a nearly massless particle that pours out of the sun and other stars by the trillions, passing through Earth as if it weren't even there. Neutrinos earned the nickname ghost particle because of how effortlessly they slip through matter. Yet neutrinos, as ghostly as they are, cannot account for more than a small fraction of dark matter. The true dark matter particles, if they exist, might be even stranger, more massive but equally shy, or something entirely different that we have yet to dream up. In laboratories deep beneath the ground, scientists have placed large, ultra-sensitive detectors shielded from the noisy world above. They filled giant vats with liquid xenon or line rooms with pure crystals, hoping that once in a while a passing dark matter particle will collide with an atomic nucleus and produce a tiny flash of light or a faint vibration of energy. These experiments sit in silence, waiting for a whisper from the dark. So far, that signal has eluded us. The detectors mostly register the quiet hiss of background particles from radioactive decays or cosmic rays that manage to penetrate the shielding. The ghosts of the cosmos continue to evade capture, teasing us with their gravitational footprints, but never showing themselves directly. We have also tried to create or detect dark matter using powerful machines like particle accelerators. In giant tunnels, we smash particles together at nearly the speed of light, hoping to momentarily conjure up exotic forms of matter that might mirror the dark matter in space. If dark matter particles can be made, we watch for energy or momentum seeming to vanish from the subatomic wreckage, a clue that invisible particles were born and slipped away undetected. So far, these efforts too have yet to reveal the nature of the ghostly matter. There is a chance that dark matter might not be a particle at all, but instead a sign that we are misunderstanding gravity on the largest scales. A few bold thinkers have proposed modifying our laws of gravity to explain the motions of stars and galaxies without needing unseen mass. However, none of those alternative theories have been able to match the wealth of evidence as neatly as the dark matter hypothesis. From the way galaxies rotate, to the patterns in the cosmic background radiation left from the Big Bang, to the distribution of galaxy clusters. All of these lines of evidence converge on the existence of some form of dark matter. And so we remain convinced that the ghosts are real, even if we cannot yet see them. The presence of dark matter has profound implications for the fate of the cosmos. Because it interacts via gravity, dark matter helped pull the universe into the structures we see today. Without it, the galaxies we know might never have coalesced in time to form stars and planets, and eventually us. And in the far future, dark matter's gravity will continue to influence how galaxies merge and cluster. It is the silent partner to visible matter, guiding the dance of galaxies from the shadows. To this day, dark matter remains one of the cosmos's most elusive secrets. We have mapped its influence across billions of light years and deduced that it dominates the mass of galaxies and clusters. Yet standing before this vast unseen entity, we are like explorers with lanterns on a dark shore, watching huge but distant waves and suspecting some enormous, invisible presence moving in the black waters beyond. We sense it through its ripples and tugging currents, but its true form lies in darkness. Someday, perhaps, we will catch one of these ghostly particles in our detectors, or create one in a collider, and illuminate what it really is. That discovery will answer one question about the universe, even as it undoubtedly raises new ones. For now, as we drift through the starlight of galaxies, we know that much of the mass around us is invisible, a celestial phantom. We move in a sea of the unseen. Even as we puzzle over this dark matter, this ghostly glue holding the galaxies together, another mystery tugs at our understanding. Dark matter's gravity works to pull things inward, to gather and bind. But out in the vast expanses between galaxies, something else is at play, something that does the opposite. It pushes outward, driving the universe to expand faster and faster. This too is invisible and poorly understood, an even more diffuse presence that doesn't clump or gather like matter at all. It is the invisible breath of the universe, gently blowing up the space between the stars and galaxies. To this next great enigma, we now turn our gaze, as we seek to understand the force behind the universe's accelerating expansion. The universe is expanding, and not in the slow, steady way astronomers once expected, but with a mysterious acceleration that has left us humbled and astonished. By the late 20th century, scientists already knew that galaxies are flying apart from one another, carried by the expansion of space that began with the Big Bang. They thought gravity, the pull of all matter on itself, would gradually slow this expansion over time. Perhaps, they imagined, the expansion might even halt one day and reverse into a collapse. To find out, astronomers measured the universe's expansion rate by observing distant exploding stars, supernovae, as cosmic mileposts. What they discovered was startling. Those distant supernovae were dimmer and farther away than expected, as if pushed outward by extra expansion. Rather than slowing down, the expansion of the universe was speeding up. Some unseen influence was overcoming gravity on the largest scales, blowing up space ever more rapidly. This revelation felt as if we had uncovered a hidden breath in the cosmos, an imperceptible wind that fills the sails of galaxies and carries them apart. Scientists named this perplexing phenomenon dark energy. The term dark simply signifies our ignorance. Much like dark matter, it's not literally dark, just unknown. And energy, reflects that it is something woven into the fabric of space, causing space to expand faster and faster. In essence, dark energy is like a pressure or tension imbued in the emptiness of the universe, a kind of anti-gravity that drives galaxies away from each other. To visualize this, imagine the universe as an enormous balloon. Galaxies are like tiny dots on the surface of that balloon. As the balloon inflates, every dot moves away from every other dot. Now imagine that the balloon not only expands, but does so at an ever-increasing pace, as if some invisible bellows were steadily blowing it up more and more. Dark energy is akin to that invisible air being pumped into the cosmic balloon, an unseen force causing the expansion to accelerate. It is the invisible breath of the universe, gently but relentlessly pushing the cosmos outward. What is the source of this repulsive cosmic push? One idea is that empty space itself has energy. Even when you remove all matter, all particles, all light, the vacuum is not truly nothing. Quantum theory tells us that even in complete darkness, particles are momentarily flickering in and out of existence. The vacuum seethes with subtle energy. This energy of empty space, if it exists as theorized, has a strange property. Instead of pulling things together like gravity from mass does, it acts repulsively, stretching space itself. In fact, Einstein's own equations of general relativity allowed for such a phenomenon. He introduced a term called the cosmological constant, essentially a uniform energy-filling space, to hold the universe static against gravity's pull, though he later discarded it when expansion was discovered. Now it appears something like that cosmological constant is real after all, propelling the acceleration of the cosmos. The irony is not lost that a concept once added as a mathematical fix may indeed reflect a deep truth about our universe. Dark energy is extraordinarily elusive, in part because it doesn't clump or cluster like matter does. It is uniform, spread evenly through space, quietly doing its work everywhere at once. You cannot bottle it up or shield yourself from it. It flows through the cosmos as a whole. As the universe grows, the dark energy within each new volume of space also grows, as if new breath fills in with the expanding volume. Unlike matter, which dilutes as space expands, imagine spreading out a set amount of gas in a larger and larger room. Dark energy seems to maintain a constant density, or something close to constant. This means that as space stretches, the total amount of this energy increases, fueling yet more expansion, a kind of positive feedback that drives the acceleration. Today, dark energy dominates the universe's energy balance. Roughly 70% of the total contents of the cosmos appears to be this strange, accelerating influence. Dark matter and ordinary matter make up the rest, with ordinary matter, the stuff of stars, planets, and people, being only a few percent. It's a humbling realization. Everything we find familiar, all the galaxies and glowing gas, is just a small icing on a vast invisible cake. The majority of existence comes in the form of these dark ingredients we have yet to truly comprehend. We see the effects of dark energy most clearly on the grandest scales. As galaxies recede from each other, the distances between far-flung galaxy clusters grow at an ever-increasing rate. Over the last few billion years, dark energy has been steering the universe into a new era where gravity's influence over large distances wanes, and this expansive push reigns supreme. Galaxies that are now on the cosmic horizon will, in the far future, slip beyond it, disappearing from our view as space between us and them stretches faster than their light can travel to reach us. In time, if the acceleration continues, more and more distant galaxies will vanish from visibility, like boats sailing over a distant ocean horizon, never to return. What will become of the universe under the influence of this dark energy? If this mysterious force remains constant or close to constant, the universe will keep expanding faster and faster forever. Distant galaxies will not only become unreachable, eventually their light will no longer reach us at all. Eons from now, an observer in our galaxy, or whatever has merged with it by then, might see only a few nearby galaxies, perhaps just the gravitationally bound remnants of the Milky Way, Andromeda, and our small neighbours, while everything else has faded into an unobservable darkness. The sky of the far future could be mostly black, devoid of the countless galaxies that adorn it today, all thanks to the relentless push of dark energy. Some scientists have speculated that dark energy could change over time. What we call dark energy might be a dynamic field that grows stronger or weaker in different eras. If it were to grow stronger in the future, it might lead to a catastrophic scenario dubbed the Big Rip, in which the expansion becomes so violent that it eventually overcomes even the forces holding galaxies, stars, and eventually atoms together. In that nightmare cosmology, everything, down to the fabric of matter itself, would be torn apart billions of years from now. On the other hand, if dark energy were to weaken or reverse, the universe's expansion might slow again. Conceivably, it could even halt or recollapse in a distant future big crunch. However, all current observations suggest that dark energy is not changing rapidly in that way. It seems either constant or very gently evolving, consistent with the cosmological constant idea. So the most likely fate, as far as we can tell, is an ever-expanding, ever-emptier universe. The notion that a calm, unseen force pervades the cosmos and will determine its destiny is deeply profound. It's as if the universe, in its old age, has exhaled a gentle sigh that will echo for eternity. This invisible breath, so faint we only detected it by its astonishing outcome, speaks to the vast scales on which physics can surprise us. We find ourselves in a universe where the unknown isn't just at the margins. It dominates the entire picture. We gave it a name, dark energy. But that name is a placeholder for our ignorance and our wonder. We are like children watching a magic trick, seeing the handkerchief dance in mid-air, but not yet knowing what makes it move. For now, dark energy remains a ghostly presence woven into the fabric of reality, quietly accelerating the expansion. In every slice of space around us, it works its subtle magic, virtually undetectable to our senses, yet altering the course of the cosmos. It is both eerie and oddly poetic that the emptiest parts of space, the voids between galaxies, carry this latent power. As we contemplate this cosmic acceleration, we come face to face with the limits of our cosmic vision. The faster the universe expands, the more it carries portions of itself out of our sight. Already, there are distant galaxies whose light will never reach Earth, because space is stretching so swiftly that those light beams are forever beyond our grasp. There exists a horizon around us, a cosmic veil beyond which we cannot see, not because something physical blocks our view, but because the universe hasn't existed long enough for light from those regions to arrive. Dark energy, by speeding up expansion, ensures that this horizon is absolute. Regions of space beyond a certain distance will remain forever hidden, as if painted on a canvas we can never touch. Our journey now leads us to consider that horizon, to peer as far as we can and wonder about what lies beyond. We have followed the invisible breath of expansion to the edge of the known universe, to the very limits of what light can show us. Beyond that lies a realm we can only imagine, a realm behind the cosmic veil. Let us now venture to that boundary and beyond in our thoughts. Stand now with us at the edge of the known universe, gazing out into the deep beyond. Out there, past the reach of our strongest telescopes, lies the domain of the observable universe. And beyond that, perhaps an infinity that we cannot see. The observable universe is like a giant sphere centered on us, about 46 billion light-years in radius, marking the farthest distance light has traveled to reach Earth since the cosmos began. It isn't a physical boundary one could touch or cross in a spaceship. Rather, it's a limit set by time and light. We peer outward and backward in time as far as light allows. But beyond that distance, the universe is veiled in darkness, simply because its light hasn't had enough time to reach us. When we look up at the night sky, we are essentially looking into a bubble of space-time from which light has had time to arrive. That bubble has a finite size because the universe itself has a finite age, around 13.8 billion years. Light from anything farther away is still en route, or may never reach us at all if the space between us and it is expanding too quickly. This means there are galaxies, uncounted and unseen, beyond the horizon of our cosmic vision. They are as real as the galaxies we can observe, full of stars and planets and perhaps life. But they will forever remain outside our view, their light destined never to grace our skies. It is a profound and humbling thought. The portion of the universe we can see might be just a tiny patch in a vast, possibly infinite expanse. If the universe is indeed infinite, then beyond our observable limits, galaxies continue on and on without end. In such an endless cosmos, every possibility might exist somewhere far out there. There could be stars with planets much like our own, civilizations under alien suns, and wonders we cannot imagine, all forever beyond our reach. It stirs the imagination to consider that in an infinite universe, there might even be regions where the arrangement of stars and galaxies accidentally mirrors our own little corner, perhaps even another Earth, with someone very much like you, looking up and wondering what lies beyond their own sky. These are fanciful musings on the theme of infinity, of course, but they highlight how limited our perspective truly is, confined to one small bubble of observation. What if the universe is not infinite, but somehow curves back on itself? This is another possibility allowed by Einstein's theory of space-time. Space could be curved in a way that has no edge, like the surface of a sphere has no edge, but is finite in area. If our three-dimensional space is curved into a finite volume, travelling far enough in one direction might, in principle, bring you back around to your starting point, though the scale of such curvature would be enormously larger than what we can see. We have tried to detect any hint of such curvature by observing the geometry of the cosmic microwave background and the distribution of galaxies. So far, all measurements suggest that space is very nearly flat on large scales. If it is curved closed, the curve is so gentle that the full circle would be far larger than the observable universe. In either case, infinite or closed, there is no wall at the edge of space, no glass dome containing the galaxies. The universe doesn't simply end beyond our sight. It continues, in one form or another, beyond the cosmic veil. There is another kind of veil, the veil of time. As we look outward to greater distances, we are also looking back in time. The farthest light we can see comes from about 380,000 years after the Big Bang. Before that epoch, the universe was a hot, opaque plasma, a fog of particles so dense that light could not travel freely. When the cosmos cooled enough for atoms to form, space suddenly became transparent, and a flood of light was released. That primordial light has been traveling for nearly 13.8 billion years, stretched by the expansion of the universe into the faint glow of microwaves we detect today. We call it the cosmic microwave background, and it is a literal wall of light beyond which we cannot see with traditional telescopes. It's as if the young universe drew a curtain beyond which photons carry no information to us. This ancient curtain, the cosmic microwave background, is a veil in time, marking the limit of our observational reach into the past. We see it as a faint afterglow that bathes the entire sky, a whisper of the fireball that once filled the cosmos. With sensitive instruments, we have mapped this background and found it nearly uniform, with tiny ripples and blotches that represent the seeds of galaxies and clusters to come. But no matter how we refine our instruments, we cannot see with light beyond that wall. Even our most powerful telescopes, like the Hubble Space Telescope and its successor, the James Webb Space Telescope, can only peer back so far in time. Webb has revealed infant galaxies forming just a few 100 million years after the Big Bang, pushing against the limits of the observable timeline. Yet even Webb cannot penetrate further. The universe before that era is shrouded behind the bright curtain of the primordial plasma. Does that mean we will never glimpse what happened before that time? Perhaps not with light, but there are other messengers. Scientists hope that one day we might detect the cosmic neutrino background, a diffuse sea of primordial neutrinos that decoupled from matter even earlier than light did, mere seconds after the Big Bang. Even more tantalizing is the possibility of capturing primordial gravitational waves, ripples in space-time itself, set off by events in the infant universe, such as the epoch of inflation. These gravitational waves, if found, could carry information from fractions of a second after the Big Bang, piercing through the veil that the opaque early plasma placed before our view. In this way, we might extend our reach slightly beyond the curtain of the cosmic microwave background, using tools other than light to peer into the universe's beginnings. Still, even if we reconstruct the story of the very early universe, we face the eternal barrier of the observable horizon in space. That horizon is like standing on the shore of a vast ocean at night. We can see to the line where water meets sky, but we know beyond that line the ocean continues, unseen. Our observable universe is that cosmic shore, and the endless ocean beyond is the rest of the cosmos, perhaps infinitely large and richly populated with galaxies. We send out our probes and build bigger telescopes to reach a little further. But no matter what we do, there will always be a horizon, always a limit to how far we can go by any physical means. This realization can be both sobering and inspiring. On one hand, it reminds us of our cosmic smallness. We will never know or visit so much of the universe. On the other hand, it invites us to imagine what could lie beyond, secure in the knowledge that reality is likely far grander than what we can directly observe. The cosmic veil keeps its secrets, but it also spurs our curiosity. What lies beyond our observable universe? The most straightforward answer is probably more universe, much like what we see, because there's no evidence that the properties of the cosmos abruptly change at the edge of our vision. The same laws of physics, The same tapestry of galaxies and dark matter likely extend far past the horizon. There could be regions where galaxies are arranged differently, maybe areas with higher or lower density, but on average, it should look similar to our part of the universe. However, because we cannot see those regions, there's always room to speculate. Might there be pockets of the universe with different qualities? Perhaps where certain physical constants take on slightly altered values, or regions that evolved in unusual ways, producing phenomena we haven't observed. We don't have evidence for such differences, but the question remains open as long as those areas are beyond empirical reach. The concept of a multiverse, many universes with possibly different properties, goes even further, and we'll explore that soon. But even within what we consider our single universe, the parts forever beyond our sight could be thought of almost as separate realms. They will never affect us, nor we them, given the limitations of light and time. In a practical sense, they might as well be their own universes, isolated by distance and the expansion of space. Before we step fully into the realm of multiple universes and speculative realities, take a moment to appreciate how remarkable it is that we, tiny beings on a small planet, have deduced so much about the grand structure that surrounds us. We have measured the shape of space, glimpsed the afterglow of creation, and identified that there is a horizon to our knowledge. We have, in a sense, felt the fabric of the cosmic veil with our fingertips, even if we cannot lift it entirely. Each discovery about the universe's vastness has expanded our perspective and shown that the cosmos is larger and more mysterious than we previously knew. Now, standing at this conceptual shoreline, our gaze turns to the possibility that what we call the universe is but one bubble in a frothing sea of universes. Could it be that there are entirely separate realities, with different laws or dimensions, existing parallel to our own, forever out of reach, except perhaps for the faintest whispers? The idea of a multiverse beckons, a grander cosmos in which our entire observable universe is just one small part. It is to these echoes of other universes that we now turn, pushing our imagination beyond even the cosmic veil we know. For generations, humans have wondered if the universe we see is the only one. Could there be other universes outside our own, like islands beyond an ocean horizon, utterly separate from our reality? The idea of a multiverse, a collection of many universes, sounds like science fiction, yet it arises naturally in several scientific theories. It's a bold extension of our cosmic perspective, where once we had to accept that our planet is not the center of the solar system, and our galaxy is but one among billions. Now we ask if even our entire universe might be just one of countless others. If true, it would mean that the vast expanse of galaxies we call the cosmos is just a small region in an unimaginably larger and more diverse metacosmos. What might these other universes be like, and how could they exist? One leading idea comes from the theory of cosmic inflation, the blisteringly fast expansion that may have occurred in the first instance after the Big Bang. Inflation was proposed to explain why our universe is so uniform on large scales, among other puzzles. But many inflation models have a strange consequence. Inflation doesn't end everywhere at once. While it stopped in our region, allowing our Big Bang to bloom into stars and galaxies, inflation might still be raging on in faraway regions beyond our observable universe. Occasionally, here and there, inflation would stop in other patches, each patch becoming a new bubble universe with its own Big Bang separate from ours. In this picture, reality is like an ever-growing foam of bubbles. Our observable universe would be one bubble that expanded and cooled, but outside it, other bubbles are continuously inflating and sprouting off. Each bubble might have its own laws of physics or values for fundamental constants set by the conditions when it formed. In one, gravity might be stronger. In another, the spectrum of light or the types of particles might be entirely alien. Most of those universes might be sterile or strange, but a few could, by chance, have properties that allow stars, planets, and perhaps life, just as our universe does. It's a mind-boggling idea. A multitude of universes, each indifferent to the others, floating in a higher reality, like galaxies separated by immense voids. Can we find any evidence that this is more than just a bold theory? Directly, probably not. By definition, other universes are separate from ours, and no light or signal from them can reach us if they are truly distinct. But some scientists have proposed that if another universe's bubble once drifted close to ours in the very distant past, the two might have brushed against each other or even collided before pulling apart. If so, maybe a faint bruise was left behind, a subtle pattern in the cosmic microwave background, perhaps a circular ripple, or an odd cold spot that our standard cosmology struggles to explain. Indeed, there is an unexplained cool region in the microwave background maps, and one hypothesis, highly speculative, is that it might be the scar of a long-ago collision with another universe's bubble. Most experts are skeptical and lean toward more mundane explanations. But it's intriguing to think that our sky could hold even a hint of something beyond everything we know. Another vision of the multiverse emerges from the realm of quantum physics. In the microscopic world, particles don't have definite states until they are observed. Instead, they exist in a haze of probabilities. One interpretation of this strange behavior is that every time a quantum event could go multiple ways, the universe splits, following each possible outcome in different branches. According to this idea, often called the many worlds interpretation, reality is constantly branching into countless parallel timelines. In each one, events unfold differently. There could be another version of you in a parallel universe who made a different life choice, or a universe where an asteroid never wiped out the dinosaurs and they evolved into intelligent beings. These parallel universes are not separated by distance in some higher space, but by a separation in their quantum state. They occupy the same physical space as us, but in a different branch of reality, never interacting with our own. If this picture is correct, the multiverse isn't just out there beyond the cosmic horizon. It's right here around us, with invisible worlds branching off at every moment. It's a beautiful and disconcerting idea that every decision, every random outcome, creates a new universe as real as ours. There are even more exotic multiverse notions. Some theories in advanced physics suggest extra-spatial dimensions beyond the familiar three. Our universe could be like a membrane, a brain, floating in a higher dimensional space. Other brains might float nearby, representing parallel universes with their own three-dimensional spaces, and perhaps their own laws of nature. Normally, we'd never know if they were there, since our particles and forces are confined to our own brain like ink on a page. But perhaps gravity, which interacts with space-time itself, can leak a little into the space between brains. If so, there might be a way for these parallel universes to make their presence known through subtle gravitational effects. Physicists have even speculated that microscopic black holes appearing in high-energy particle collisions could be a sign of extra dimensions, a tantalizing but so far unobserved echo of other realities. Another concept reaches not outward in space or into quantum possibilities, but backward and forward in time. The idea of cyclic universes. In this vision, the Big Bang was not the absolute beginning, but rather the rebirth of a universe that came before. Our cosmos might go through infinite cycles of death and rebirth, perhaps expanding from a Big Bang, then cooling and spreading out, and maybe eventually contracting or dissipating, only to spark into a new Big Bang, starting the process anew. Sir Roger Penrose, a renowned physicist, has even proposed that the universe's accelerated expansion may, trillions of years hence, make the universe so cold and empty that it becomes, in a curious way, indistinguishable from the ultra-hot, dense state that started our Big Bang, thus giving birth to a successor universe. He and his colleagues have claimed to find traces in the cosmic microwave background, subtle concentric ring patterns that might be echoes from violent events, like titanic black hole collisions in a universe that existed before ours. The evidence is highly contentious and not widely accepted, but the notion is poetic. We might be seeing a whisper of a previous cosmos, a message from an earlier universe that lived and died before our own began. At this point, these multiverse ideas remain speculative. They are fascinating attempts to answer profound questions. Why is our universe the way it is? Why do the fundamental constants have the values that allow stars and life? Could it be that we live in one of many universes, and we happen to be in the one that can support observers like us? Because, if it didn't, we wouldn't be here to notice. This line of thinking invokes what's known as the anthropic principle, the idea that the observable universe's properties are as they are, in part because only certain types of universes could develop observers. If countless universes exist, then it's no surprise that at least one has conditions just right for life, and we find ourselves in it. It's a philosophical shift as much as a scientific one, extending Copernicus's principle of mediocrity, that we're not in a special place, to its ultimate conclusion. Even our entire universe might not be uniquely favoured or central in the grand scheme. So, do we have any true echoes of other universes that we can detect? As of now, no definitive signal has announced itself from another cosmos. Each hint so far, a strange cold spot in the sky, an odd anomaly in a physics experiment, a curious mathematical implication, has been intriguing, but inconclusive. The multiverse, if it exists, may forever elude direct confirmation, hidden behind walls of causality or dimensions we cannot access. But that does not render the idea meaningless. The value of the multiverse concept is in expanding our sense of what reality could be. It challenges us to think bigger, to accept that the cosmos might be far more extensive and varied than what we can see or test. In the end, whether there are countless universes or only our one, the mysteries of existence run deep. We find ourselves in a universe full of wonder, black holes where light sleeps, invisible matter and energy sculpting and propelling galaxies, horizons beyond which entire realms lie hidden, and perhaps a multiverse extending the stage of creation into the widest panorama imaginable. Each mystery we have touched upon is like a fragment of a grand puzzle, and each answer we uncover often leads to new questions. Our pursuit of these cosmic secrets is a journey with no clear end. And maybe that is a beautiful thing. As you lie back and gaze at the night sky, you can feel the depth of it all. The stars twinkle, ancient light reaching us across the void. Each star, a sun in some distant corner of our universe. Yet beyond those stars are billions more in galaxies we can barely glimpse. And beyond those galaxies, the unknown expanse stretches out, perhaps forever. In the quiet, under the canvas of darkness, we ponder the possibilities. What else is out there, unseen? Are there other universes where other beings see a different sky, or where no one is there to see at all? In the face of such vast unknowns, we might feel small, but we are also participants in the great cosmic story, observers gifted with curiosity and imagination. Our minds can voyage to the edge of time and space, and even beyond, conjuring visions of other universes. In doing so, we weave meaning into the silent darkness. Ultimately, the secrets of the cosmos are not just out there among the stars and galaxies, but also within us, in our desire to know and understand. The universe invites us to wonder, to dream with eyes open, as we ponder these space mysteries, from sleeping light to ghostly matter, from invisible breaths to cosmic veils and echoes beyond. We find a strange serenity in not having all the answers. There is a peaceful awe in simply recognizing the grandeur and mystery that surround us. Our journey through these cosmic mysteries does not end with neat conclusions. Instead, it ends with an open sky full of questions, a gentle reminder that there will always be more to learn. In this uncertainty lies the allure. As you drift into sleep, let these grand questions float through your mind like stars in the night. Perhaps there are other universes whispering just beyond reach. Perhaps our universe's story is but one chapter in an endless book of realities. We may never know for sure, but it is enough, for now, to ponder and to marvel. In the vast darkness of the cosmos, our imaginations light a few candles, and that gentle glow guides us onward, ever curious and ever hopeful, beneath the infinite sky. As we drift deeper into the cosmic night, a question quietly echoes through the silence. Are we truly alone in this vast expanse? All around us, countless stars sparkle like distant islands in a boundless sea. Each star might hold its own family of worlds, some perhaps much like our own. The sheer number of possibilities is almost beyond comprehension. Beneath the tranquil canopy of darkness, the universe teems with potential. Countless points of light that could harbour oceans and atmospheres, clouds and continents, maybe even life gazing back at us across the light years. For as long as humans have looked up at the sky, we have wondered about companions out there in the cosmic ocean. On clear nights long ago, our ancestors watched the stars and spun stories about gods and heroes dwelling among them. Today, we continue that tradition in our own way, not with myths, but with science, listening and searching for any sign that we are not alone. With giant radio telescopes turned toward the heavens, we cup our ears to the universe, hoping to catch the faintest whisper from a distant world. In the quiet control rooms of observatories, scientists sit through the night, sifting through static and starlight for something meaningful. The signals that arrive are subtle and delicate, a faint ripple in radio waves, a gentle blip in a sea of background noise. Mostly, it is an endless hush, just the natural hum of cosmic phenomena. But every now and then, there is a moment that makes hearts race. An unexplained signal, a pattern that doesn't seem random. Could it be a greeting from another intelligence? Or just a quirk of nature we haven't seen before? These moments remind us how eager we are to find a connection in the dark. One famous night in the late 1970s, a radio telescope listening to the sky heard an unusual burst of energy. It lasted just a minute or two, but it was unlike anything normally heard from space. An astonished researcher scribbled, "Wow," next to the printout. And so this mysterious signal became known as the wow signal. It was a tantalizing whisper from the stars, a beacon of possibility that flared briefly and then vanished, never to repeat. To this day, we cannot say for sure what caused it. Maybe it was a natural cosmic phenomenon, a star's hiccup, or an echo of some cosmic collision. But maybe, just maybe, it was the cosmic equivalent of a friendly wave, a signal sent intentionally or unintentionally by another form of life. The uncertainty lingers, keeping our imaginations alight as we scan the skies. Our search for company in the universe has only just begun, and we've tried not only to listen, but also to speak. In the 1970s, even as we were straining our ears, we sent out our own greeting. The Voyager spacecraft, little robotic explorers, were launched into the unknown, each carrying a golden record filled with the sights and sounds of Earth. On those records are hellos in dozens of languages, the music of whales and of Beethoven, the laughter of children, a heartbeat and a rainstorm, a capsule of our world, drifting through the cosmic dark. Today, those voyagers are silently sailing farther and farther away, beyond our solar system into the interstellar sea. Perhaps one day, millions of years from now, some distant intelligence might find one of them and discover a small sample of life from a planet called Earth. Even our everyday chatter on this planet has been leaking into space for decades, forming an ever-expanding bubble of radio waves announcing our presence. Early television broadcasts, crackling radio dramas, the Morse code beeps of long-ago transmitters, all have been travelling outward at the speed of light, washing past nearby stars. If there are listeners out there with sensitive ears, perhaps they have already caught the faint signal of a 1930s jazz tune or an old news report from our airwaves, arriving from the tiny blue dot we call home. In a sense, we have been talking to the cosmos without even meaning to, our whole civilization sending out an accidental greeting in all directions. As we listen and send, our technology has grown ever more keen. We now know of thousands upon thousands of planets orbiting distant stars. Where once we could only speculate that other solar systems existed, today we have evidence of them everywhere we look. There are more planets than stars in the Milky Way galaxy, and many of those planets are small and rocky like Earth. Some orbit in the gentle warmth of their sun's habitable zone, where liquid water might pool on the surface under protective skies, the kind of conditions that nurtured life on our own world. When we gaze at those stars now, we know there are unseen worlds circling them, real places with landscapes and climates of their own. It's impossible not to wonder what those worlds are like, and if something might be living there under alien suns. We have even discovered planets stranger than anything we once dared imagine. There are worlds with two suns in their sky, casting twin shadows on the ground. There are giant planets so light and puffy that they could float in a colossal cosmic ocean, and others so heavy and dense that a lump of their matter would outweigh mountains. Some planets might be covered entirely in deep global oceans, with not a single island in an endless sea. On some, it may rain in exotic ways, perhaps droplets of molten glass falling through searing winds, or clouds of scarlet dust painting the skies. The cosmos seems to delight in variety. Each new world we find is a fresh canvas on which nature experiments. And if life can arise given the right ingredients and a bit of luck, perhaps it has done so on some of these far-flung shores, in forms more wondrous than we can imagine. Picture a sunset on one of those distant worlds. The sky might not be blue at all, but a pale violet or deep orange, tinted by alien molecules in the air. Two suns could be descending together, their overlapping light turning the horizon into a dreamscape of colours unknown on Earth. Under that strange twilight, maybe gentle creatures drift in a warm, alien sea, their translucent bodies glowing softly as they ride the currents. Or perhaps on a high plateau of rock and crystal, tree-like forms stretch out shimmering fronds to catch the radiance of two fading suns, in a kind of photosynthesis that turns starlight into nourishment. These scenes live only in our imagination for now, but they remind us that life, if it exists elsewhere, could be truly extraordinary. The universe is vast enough to allow for endless surprises. The ingredients for life, we've found, are not unique to Earth. In giant clouds between the stars, our telescopes have detected organic molecules, the carbon-rich building blocks of biology. Complex chemicals like amino acids have been discovered in meteorites that fell to the ground, and simple sugars and precursors to life's chemistry float in the icy comets that wander the solar system. It seems that the universe has been sprinkling the raw materials of life far and wide, like seeds waiting for fertile soil. And life itself, at least here, shows incredible resilience. We find living microbes thriving in boiling hot springs, in the crushing darkness at the bottom of the ocean, sealed inside rocks deep underground, and clinging to ice in the coldest polar nights. Hardy organisms endure in places of intense radiation and complete darkness. Tiny creatures even survived a journey outside a spacecraft, exposed briefly to the vacuum of space, and lived to tell the tale. If life can exist in such extremes on Earth, might it not also endure in the frozen oceans of Jupiter's moon Europa, or in the sulphurous clouds of Venus, or beneath the rusty soil of Mars? Nature seems bent on life whenever given half a chance, filling every niche with something that lives and breathes. So we pay close attention to every hint and clue. A faint whiff of methane gas on Mars makes us wonder if something is stirring beneath the Martian surface. An odd chemical pattern in the atmosphere of a distant exoplanet has us debating if it could be the byproduct of alien microbes. When scientists thought they glimpsed a rare gas in the clouds of Venus, a gas that on Earth is linked to living organisms, it set off waves of excitement at the thought that something might be alive in those acidic skies. Later studies made that signal fade, a reminder that we must be careful and patient. The cosmos reveals its secrets slowly, and often we find a mundane explanation at first. But each hint, each anomaly, keeps the flame of curiosity lit. We know that extraordinary claims require extraordinary evidence, so we check and double-check. In the meantime, just the possibility keeps us inspired. The possibility of life beyond Earth feels closer now than it ever has in our history. We can easily imagine that somewhere in the galactic sea, another civilization might be contemplating the same question from their own vantage point, perhaps on a planet orbiting a dim red sun under a sky filled with crimson twilight. There are thinkers with eyes different from ours, looking up and wondering if someone else is out here. Perhaps they too have built instruments, gazing at the stars that dot their alien heavens, straining for a hint that they have company in the great darkness. Across the light years, we might be like two distant ships on a dark ocean, each shining a lantern, hoping the other catches the glimmer. We have yet to see those distant lanterns for certain, but we imagine them nonetheless. It is a profound thought that the universe might be teeming with life, or conversely, that it might be almost empty, except for us. Either possibility reshapes how we see ourselves. If life is common, then the cosmos could be rich with strange and wonderful beings, an endless tapestry of biology playing out on billions of worlds. If we could visit those worlds in our mind's eye, we might witness sky-filling creatures drifting gently through the clouds of a gas giant, or glowing forests dancing under the auroras of a far-off moon. Life might take forms beyond anything on Earth, adapted to environments we can barely conceive. On the other hand, if life, especially intelligent life, is exceedingly rare, if perhaps we are the only ones in a vast loneliness, then our responsibility is immense. On our small planet, we would carry the only flame of awareness, a solitary beacon of life in a quiet universe. That would make every living thing here, every culture and dream, every moment of understanding, indescribably precious. We would be the universe's sole witnesses, the only way for the cosmos to know itself, surrounded by an awful lot of silence and dark. For now, we simply do not know which of these realities is true. We are cradled in mystery, surrounded by a silence that could be temporary, or could be the very nature of our cosmic neighborhood. And so we continue to listen for those whispers of life in the cosmic ocean, refusing to let the quiet be an answer. Each new star we examine, each new planet we map, we carry the question with us. Could someone be living there? And could they be looking back our way? These questions fuel our sense of wonder and drive us to explore further. Until we hear a voice or find unmistakable footprints beyond Earth, we have only our imaginations and our scientific curiosity to guide us. In the meantime, we've been sending our own messages into the dark, not just with voyagers and accidental radio leakage, but with deliberate signals as well. Once, we beamed a strong radio message toward a distant star cluster, a brief burst of information describing our planet and our species, knowing it would take tens of thousands of years to arrive. From time to time, scientists and enthusiasts have pondered how we might craft the perfect cosmic greeting, something that any intelligent ears across the galaxy would understand. In truth, we do not know who might be out there or how they might think, but the very act of trying reminds us of what we share here on Earth. In composing messages to hypothetical others, we reflect on ourselves, the common heartbeat of humanity, our mathematical languages, our simple drawings of what we look like and where we reside among the stars. All the while, the stars themselves shine on indifferently, neither confirming nor denying the existence of neighbours. They twinkle like distant beacons, each perhaps with its own secrets. Under that stellar canopy, we carry on our quiet vigil. We aim radio dishes at the sky and patiently sift through the static. We build new observatories, send up space telescopes, and invent ever more sensitive instruments to eavesdrop on the cosmos. We do this because the question of other life is so profound that even a lifetime of silence won't dampen our curiosity. We also understand that the universe operates on timescales far beyond our own. 100 years of listening is nothing next to the age of a star. If a reply to our call comes, it might only arrive long after we are gone, perhaps to delight our distant descendants. Knowing this, we persist anyway. The search itself is a kind of devotion, an expression of hope that we are willing to wait as long as it takes. And in that waiting, in that attentive silence, we have come to appreciate the voice we do know in the cosmos, the voice of life on our own world. As we press our ear to the sky, we also hear the earth's gentle chorus, the sigh of wind in the trees, the murmur of the ocean, the chatter of creatures that share this planet with us. We realize how precious this oasis is, how filled with life and sound it is, against the great cosmic quiet. Whether or not we eventually find others out there, we have this symphony of life on Earth, and it may be singular in our galaxy, or even the entire universe. That thought encourages both awe and humility. It reminds us that as much as we reach outward, we must also cherish what we already have here. Still, our gaze remains drawn to the stars. The cosmic ocean stretches out before us, vast and beckoning, its depths still largely unexplored. We cannot help but wonder what lies beyond the next wave of darkness and distance. Perhaps one day, a faint signal will appear in our data, undeniable and clear, telling us we are not alone. Or perhaps we will find unmistakable evidence on a far-off planet, a pattern in its atmosphere, or a flicker of light that says, life is here. That day would change everything. A moment of profound connection, one that generations of dreamers have hoped for. But even if that day is far away, or never comes, the act of searching is its own reward. It has opened our eyes to the richness of the cosmos and kept alive the childlike wonder that makes us human. In the stillness of a starry night, one can almost feel a gentle yearning in the darkness. Perhaps that is just our own yearning, echoed back by the void. We send our hopes and our curiosity out into the night, like messages in bottles cast upon a vast ocean, trusting that somewhere, someday, they might wash ashore. And perhaps, drifting in the darkness at this very moment, there are other bottles launched from distant shores, carrying the dreams of others, waiting to be found. We have no guarantee, but we have faith in the possibility. So we listen on, hearts and minds open. In that quiet listening, we find ourselves humming a tune of hope, a melody of longing softly carried across the cosmic sea. Maybe, somewhere out there, another lonely voice is humming the same tune, waiting for an answer. In this way, across the light years, we are connected by our questions, even before we have an answer. And as we float through the darkness, guided by curiosity and the quiet desire for connection, we remain ready, in silence and wonder, to hear at last those long-awaited whispers of life, the great silence among the stars. Beyond those hopeful whispers, there remains a vast and unsettling quiet. For all the billions of stars and the potential worlds around them, we have yet to hear a single, unmistakable echo of another intelligence. This absence of evidence can feel like a deep hush in a dark forest. You sense the immensity of the space around you, but hear nothing except your own breathing. It's a silence that raises more questions than answers. In a universe so old and so grand, one might expect it to be buzzing with life and intelligence, or at least peppered with signals crisscrossing the stars. Instead, when we point our ears to the sky, we are met with what has been called the Great Silence. This puzzling quiet is so striking that scientists have given it a name: the Fermi paradox. Enrico Fermi, a physicist of the last century, famously asked, Where is everybody? In light of the countless stars and presumably many life-bearing worlds that could exist, it's a simple question that cuts to the heart of our cosmic loneliness. If the galaxy is filled with worlds, and if some of those worlds have given rise to advanced life, then why don't we see any sign of it? Why, as far as we can tell, do we find ourselves alone, with no voices echoing across the stars? The universe is ancient, with plenty of time for life to spread and grow many times over. And yet, the skies remain eerily quiet. There are many ideas about why we haven't heard from anyone. One possibility is that life, especially complex, intelligent life, is incredibly rare. Perhaps, while simple microbes might emerge in many places, the leap to big-brained, tool-making creatures is exceedingly uncommon. Maybe in the grand lottery of evolution, the odds of another species developing technology and curiosity the way we have are astronomically low. Under that scenario, we might truly be the exception in our galaxy, a solitary beacon in an ocean of simple life or barren worlds. If so, the silence around us isn't because someone is choosing not to speak. It's because there's no one else capable of speaking within earshot. Another possibility is that plenty of civilizations have arisen, but they tend to have short lifespans. It could be that once a society becomes advanced, it also gains the means to destroy itself, or it falls victim to some catastrophe. Time and again, perhaps, civilizations bloom like delicate cosmic flowers, only to wither and disappear before they can reach out to neighbors. If many have come before us and then faded away, their radio signals might have been brief flickers that we simply missed, or their ruins might now lie cold and silent on distant worlds. In this somber view, the cosmos could be littered with the quiet remnants of those who came before, and we too must be careful with our own destiny. Then there is the thought that intelligent life might indeed be out there, but chooses not to broadcast its presence. Maybe advanced beings are observing a kind of cosmic quiet hour, staying hushed, either out of caution or indifference. Some have imagined a scenario in which there is a wise rule among spacefaring civilizations to not interfere with emerging cultures like ours, something akin to us quietly watching animals in a forest without disturbing them. In that case, we wouldn't realize they exist until we ourselves become advanced enough to notice subtle clues, or until they decide we are ready to be contacted. It's a speculative idea, but it paints the quiet, not as emptiness, but as a deliberate calm. Another simple explanation for the great silence might be distance and time. The stars are separated by such vast gulfs that even if two civilizations exist at the same moment, they might be too far apart to readily find each other. Our galaxy is about 100,000 light-years across. Imagine two civilizations on opposite ends of this island of stars. They could each send out signals or even starships, but those would take tens of thousands of years to traverse the space between. By the time any message arrives, the sender might be long gone or changed beyond recognition. It would be like trying to hold a conversation with someone when each exchange of words takes millennia. Communication under such conditions might be effectively impossible, or at least not practical. So the silence we hear could simply be a matter of enormous distance and the slow pace of light and sound in the universe. Time could be isolating us as well. Human civilization has been using radio technology for only a tiny fraction of cosmic history. Mere decades of sending signals out of billions of years that the galaxy has existed. What if other civilizations arose millions of years ago, did their experiments with communication, and then either moved on to other endeavors or vanished? Their signals might have come and gone before we ever had the equipment to notice. Likewise, there could be civilizations that will emerge long after we are gone, perhaps millions of years in the future, who will wonder the same thing and never catch our signals because by then they have faded into the background. We could simply be ships passing in the night, separated not only by space, but by epochs of time. Every time scientists have thought they found a hint of company, nature has humbled us. In the 1960s, when a steady, pulsing radio source was detected in the sky, so regular it almost seemed artificial, the discoverers half-jokingly labelled it LGM-1 for Little Green Men 1. It turned out to be a pulsar, a rapidly spinning neutron star, flashing beams of energy like a cosmic lighthouse. Not aliens at all, just an exotic star corpse ticking away in the darkness. Many times since, other strange phenomena have sparked brief excitement. A mysteriously dimming star led some to speculate about alien megastructures, only for dust to likely be the culprit. Peculiar bursts of radio energy were once thought to be possible interstellar signals, but ended up being things like distant exploding stars, or even interference from Earth's own devices. The pattern repeats. Again and again, the universe offers a mystery, and when we investigate, we find natural processes at work rather than a message from another mind. So far, nature's voice is all we've heard, and so the silence persists, and with it, a mix of emotions within us. On one hand, the solitude can feel daunting, a reminder of how vast the void is and how fragile our spark of life might be. On the other hand, there is a strange beauty in the quiet too. The night sky above, dotted with stars that do not answer, can feel like a peaceful, sleeping wilderness. The great silence among the stars is the canvas on which we project our hopes and fears. In that quiet, we find not only loneliness, but also a profound sense of wonder. It is the silence of a grand, empty cathedral, inspiring reverence and contemplation. We must remember that our search has only touched a tiny fraction of the cosmic ocean. In truth, declaring the universe empty, based on our brief, limited search, would be like dipping a cup in the sea, not finding a fish, and deciding the ocean has no fish at all. There is so much we haven't yet explored. Our radio searches have scanned only a comparatively small number of stars, and only certain ranges of frequencies. It may be that the cosmos is humming with conversations, but on channels, or in forms, we have not yet learned to detect. Perhaps other beings communicate with technologies far beyond radio waves, using methods we cannot even yet comprehend, like subtle modulations of starlight or particles that slip past us unnoticed. It could also be that the first signs of life we detect won't be a deliberate message at all, but the byproducts of life's presence, for example, the chemical fingerprints in an exoplanet's atmosphere. We may someday see the telltale glow of oxygen or other gases that betray the metabolism of alien forests or oceans, long before we pick up an actual greeting. Until then, we are left with a profound silence and our own thoughts. The Fermi paradox, the question of where everyone is, remains unanswered. Yet not all is empty. We have each other here on this world, and we have the endless intrigue of the universe to keep us company. In a way, the silence has urged us to look inward and cherish the life we do know. If we are truly alone, that fact only elevates the value of every species, every culture, every individual on this planet. It means we carry the responsibility of keeping the flame of consciousness alight in the dark, at least in our little corner of the cosmos. The great silence also pushes our imagination to soar. In the absence of answers, We fill the void with stories and hypotheses, with art and poetry about who might be out there and why they remain unseen. Perhaps the silence is not permanent. One day, out of the quiet, a signal might arrive that changes everything in a moment. Or perhaps, in the far future, it will be humanity that breaks the silence. We might venture out to the stars ourselves, becoming the very aliens we seek, turning the quiet into a chorus of new voices. For now, we tread carefully and curiously, ears perked and eyes open, marveling at the sheer quiet of the cosmic night. Under the vault of stars on a clear evening, one can feel this silence intimately. It's in the still air and the faint background whisper of the wind. The stars shine down like distant streetlights in a sleeping city, and we wonder if behind any of those lights someone might be awake. The only answer is the soft rustle of our own world, the chirp of a night creature here, the quiet breath we take, the distant roll of a wave. The cosmos offers no reply, only the same patient silence it has kept for eons. And yet, within that silence, we do not lose hope. We carry on listening and searching, our efforts like tiny candles we light against a vast darkness. Each new telescope, each new mission, we send them out like lanterns into the night to illuminate just a little more of the unknown. The quiet might simply mean the universe is waiting for the right moment or the right connection to be made. It might be the hush before a cosmic symphony, or it might be the steady state of a sparsely populated cosmos. Either way, we embrace it, learn from it, and find a way to take comfort in it. If indeed we come to discover that we are essentially alone, that too is a kind of answer. It would tell us that life is something to be guarded dearly. We would become the guardians of consciousness in a vast, unconscious expanse. If instead we eventually hear a whisper or see evidence that we have company, then the silence will have been the prelude to an exchange that could enrich us beyond measure. In both outcomes, there is a certain majesty. Either we are the sole light in the dark, or one of many lights quietly shining and waiting to connect. For now, the stars continue to sparkle in their quiet way. We continue to watch and to listen, holding both the melancholy and the wonder of this silence in our hearts. The great silence challenges us, but it also teaches us patience and humility. It reminds us that the universe does not bend to our timetable, and that answers come in their own time. And as we contemplate this deep quiet, we are gently led to an even grander realization. Not only are voices absent now, but one day, far in the future, even the stars' own voices will dim. The silence we experience in this age might one day extend to the very sources of light themselves. One by one, over unfathomable timescales, the stars will exhaust their fuel and the galaxies will grow darker. The cosmic stage that now is lit by billions of suns will eventually go dark and quiet, an even deeper silence than we know. That, however, lies in a future so distant it almost escapes imagination. Still, it is a reminder that nothing lasts forever, not even starlight. If we find the current silence thought-provoking, we can also contemplate the hush of a cosmos where no new stars are born and old ones wink out. It is toward that distant twilight of the universe that our journey now gently turns, moving from the mysterious quiet of our present cosmos into the far future, where even the stars themselves fall silent. Fading starlight, eternal night. The stars we see glittering in the night have long been symbols of the eternal. They seem unchanging, steadfast points of light that have guided travelers for millennia. But in truth, stars are born, they age, and they die, just as living things do, only on timescales that dwarf our human experience. Each star is a cosmic flame fueled by a finite supply of light elements. Over the eons, that fuel runs low, and when it does, the star's light begins to fade. Starlight, as brilliant as it is not forever. Imagine looking up at a sky where, one by one, the stars are going out. Of course, in our brief human lifetime, we won't literally see a star wink off. These changes take millions or billions of years. But on the grand scale of time, stars are continually saying their farewells. A massive star lives fast and dies young. In a few million years, it can exhaust the hydrogen in its core, swell into a bloated giant, and then end in a spectacular finale. A supernova explosion that outshines entire galaxies for a few shining weeks. That death is violent and brilliant, scattering the star's contents across space. By contrast, more modest stars like our Sun live much longer, shining steadily for billions of years. But even our Sun will not shine forever. In roughly 5 billion years, give or take, it will have burned through the core of its fuel. It will swell into a red giant, expanding so vastly that Mercury and Venus will be engulfed. And Earth, if it still exists then, will be scorched and barren. The Sun will then shed its outer layers, like a shimmering farewell veil, creating a glowing shell of gas, a planetary nebula, before its core remains behind as a small, hot ember called a white dwarf. That white dwarf will slowly cool over trillions of years, fading from white to yellow to red to black, becoming an invisible cinder in the darkness. This is the ultimate fate of many stars, not with a sudden bang, but with a quiet fading away. After shining for ages, they leave behind these remnants, white dwarfs, neutron stars, black holes, cosmic corpses that no longer shine, or shine only faintly. Right now, the cosmos is rich with the light of young and middle-aged stars, but as time marches on, the balance will shift. The big, short-lived stars will die first, going out in dramatic supernova bursts that briefly light up the darkness around them. New stars will continue to form from the debris. Indeed, our galaxy still actively weaves new stars in stellar nurseries, using the gas and dust that previous stars provided. But even this creative cycle will not last indefinitely. In the present epoch, galaxies like the Milky Way are bustling cities full of lights that continually blink on and off. There's still plenty of gas and dust to fuel new suns. Yet with each generation of stars, a bit more of that free gas is locked away in stellar bodies or blown off into intergalactic space. Trillions of years from now, the materials needed to make new stars will be largely depleted or too thinly spread. Star formation will slow to a trickle and eventually cease. The lights will begin to go out faster than new ones ignite. Think of the smallest, longest-lived stars, the red dwarfs. These tiny crimson suns sip their fuel so slowly that they can burn for hundreds of billions, even trillions of years. While larger stars live extravagantly and perish quickly, these red dwarfs are like steady candles meant to last the entire night. In the far future, long after stars like our sun have gone dark, red dwarfs will still dot the universe with their faint, warm glow. They will be the last lanterns against the encroaching dark, keeping the night at bay as long as physics allows. But even they cannot last forever. Eventually, after unimaginable spans of time, the very last red dwarf will burn through its final atoms of hydrogen. It may flare weakly as it exhausts its reserves, and then it too will settle into a black dwarf, a hypothetical object. None exist yet, because the universe isn't old enough. A cold, dark sphere, where once there was a shining star. Now imagine that distant era, a universe where no new stars are born, and all the old ones have gradually burned out or blown themselves apart. What would remain? There would be no sunrises, no starry nights, just an endless expanse of black, punctuated only by the faint afterglow of things that once were. The galaxies themselves, which today gleam with the collective light of billions of stars, will be dark, quiet islands. Planets, if any still circle the cinders of stars, will be adrift in eternal night, their skies black velvet, with not a single point of starlight. The only occasional flickers might come from the collisions of dead stars, or the slow, ghostly radiance of matter falling into black holes. But even black holes are not truly eternal. Over an almost inconceivable time span, they too will evaporate, emitting a last weak hiss of energy before fading to nothing. This vision of the far future is haunting in its stillness. After the grand fireworks of the final supernovae and the last flickers of fading suns, the universe will enter a deep and lasting slumber. Some call it the heat death of the universe, an era when all is cold and uniformly spread out, and nothing much can happen anymore. It's a state of maximum entropy, where the cosmos has run its course of energetic drama and settled into quiescence. In that final night, there are no bright galaxies, no glowing nebulae, no warmth of starlight, only the thin, diffuse whisper of particles and energy spread over unfathomable distances. The universe, so full of light and activity in its youth, will become a quiet, dark expanse. It is a melancholy thought in some ways, that all the brilliance we see now is transient, that the age of starlight will one day pass. But there is also a kind of solemn dignity in this idea of an eternal night. It's as if the universe, after eons of cosmic evolution and spectacle, finally comes to rest. The violence of supernovae, the roaring of quasars, the dance of galaxies, all of it quiets down into a serene hush. In that darkness, the cosmos will keep its secrets in silence, like a vast archive of everything that happened in the light. None of this will affect us directly. These events are so distant in the future that they almost belong to the realm of imagination. Humanity, and even Earth itself, occupies only a mayfly's flicker of time compared to such eons. But thinking about the fate of the stars can put things in perspective. We live in a universe caught in the act of shining. We're fortunate to witness a sky bedazzled with thousands of stars, to bask in the warmth of a sun that is still robust and golden. We inhabit the cosmos during a youthful, vibrant time, not the cold darkness that is to come. It's a reminder to cherish the starlight while it's here, just as one might savor the last hours of daylight before a long winter night. Moreover, the story of fading starlight isn't only about endings. It's also about transformations and new beginnings. Every time a massive star dies in a blaze of glory, it isn't merely vanishing, it's creating. In the furnace of that explosion, and in the dying embers of stars like our sun, new elements are forged. Carbon and oxygen, iron and silver, gold and uranium, and so many others. These are the ingredients of planets and of life itself. When a star ends its life, it scatters those enriched materials into space, seeding the clouds that will form new stars, new planets, and perhaps new living beings. In fact, our own existence is tied to these stellar life cycles. The atoms in our bodies were forged in the hearts of ancient stars and released in their final moments. Long before our sun and earth formed, previous generations of stars lived and perished in this corner of the galaxy, bequeathing the ingredients that would one day become us. The calcium in our bones, the iron flowing in our blood, the oxygen in our lungs. Those atoms were once part of a star that exploded or shed its layers long ago. We truly are made of star stuff, as the saying goes, born from the ashes of stars. So, as the stars fade in the far future, we remember what their light has given while it lasted. The eventual darkness of the universe does not erase the brilliance that came before. The legacy of starlight is written in every grain of dust and every atom that was forged in those stellar furnaces. Even in a universe gone dark, that matter, the ashes of long expired suns, will remain as a testament that once stars shone and gave of themselves. Perhaps some incredibly distant future intelligence, if any could survive in that far epoch, might look out at the quiet remnants and infer the glorious past, much as we look at ancient ruins and imagine the vibrant civilizations that built them. In that way, the memory of starlight could echo forever, even in an eternal night. For us, here and now, the fading of starlight is still just a concept to ponder. The stars in tonight's sky will also be there tomorrow night, and for countless nights to come. The cosmos is not rushing toward darkness anytime soon on a human timescale. We have a long, bright road still ahead of us in our galaxy before the lights begin to wink out. In the meantime, we can marvel at the knowledge that we stand at a midpoint of sorts, early enough to see a universe full of activity and light, and aware enough to foresee a time when that will no longer be so. This perspective can fill us with a gentle appreciation, a kind of cosmic gratitude for the luminous era we live in. Now, our journey through the cosmos leads us from this contemplation of the far, dark future back to ourselves, to the intimate connection we have with those stars that will one day fade. Before the universe ever reaches that cold silence, it has done something miraculous. It has given rise to life, to thinking beings made of the dust of stars. It is to that connection, our origins in stardust, that we now turn. For even as starlight will eventually vanish, it lives on right now within us. We are, in the most literal sense, children of the stars, and their story is our story too. Children of stardust. We are all made of stars. It's a poetic statement, and also a scientific truth. Every atom in your body, aside from some hydrogen, which was born in the universe's first moments, was forged in the heart of a star that lived and died long before our sun ever shone. When we say we are children of stardust, it is not mere metaphor. It is the literal history written in our blood and bones. Consider the journey of a single atom in your body. The calcium in your tooth, for instance, began as pure energy in the young universe. That energy became matter, simple hydrogen and helium, in the primordial dawn. Eons later, within the fiery core of a massive star, hydrogen atoms fused into heavier elements. Through successive generations of stellar alchemy, calcium was formed. That star eventually met its end, perhaps in a supernova that scattered its enriched guts across space. Some of that calcium-bearing dust found its way into a cloud that was coalescing to form new stars and planets. Our sun ignited at the center of that cloud, and around it, planets took shape from the leftovers. One of those planets was Earth. On Earth, through billions of years of geology and evolution, that calcium became part of rocks, then part of living tissue, eventually forming the tooth of a living being that smiles and speaks. You. In this way, that single atom completed an incredible journey, from the core of an ancient star to a human life. Each of us carries a treasure trove of such cosmic relics. The iron in your blood, which carries oxygen to your cells, was forged in the explosive death throes of a star that ended its life long before Earth existed. The carbon in your muscles and the nitrogen in your DNA were cooked up in stars or in the supernovae that punctuated their demise. Even the gold in a ring on your finger or a watch on your wrist likely came from the collision of two ultra-dense stellar remnants, neutron stars, merging in a flash of unimaginable power that created heavy elements and flung them into space. We walk around every day composed of this ancient stardust, mostly unaware of the epic cosmic saga each part of us has travelled through. When we gaze at the night sky, we are not just looking at distant, alien points of light. We are looking at something intimately connected to us. We are looking at our long-lost relatives, in a sense. The stars are our ancestors. They provided the raw materials for life, and now here we stand, conscious and curious, able to contemplate them in return. It's a beautiful kind of symmetry. The universe creates the means to know itself. Through us, through our eyes and our minds, the cosmos can appreciate its own splendor. We are a way for the universe to know itself, having been born from its very substance. This connection can be a deeply comforting thought. When you feel alone or insignificant under the vast sky, remember that you are intrinsically part of it. The substance of your body is kin to the substance of galaxies. You have more in common with a nebula across the galaxy than you might think, because you share the same building blocks. In fact, the whole Earth and everything on it is made from stardust. Every mountain, every grain of sand, every drop of ocean water, every leaf on every tree, all are composed of elements synthesized in stars. We are all related at the elemental level, not just all people, but all of nature, every creature and creation. The calcium in a bird's eggshell, the carbon in a blade of grass, the phosphorus in a whale's bones, all were forged in stellar furnaces and delivered here by stellar journeys. Realizing this fosters a sense of unity and belonging. We often think of ourselves as separate from other animals, separate from the ground we stand on, separate from the sky above. But in truth, we are woven from the same fabric as the cosmos. The boundary between us and the universe is far thinner than it seems. In a very real way, the universe is within us, just as we are within the universe. Our atoms do not carry labels. They drift through the cosmos over billions of years, forming stars, planets, and eventually living beings, then dispersing again. The atoms in your body have existed for billions of years and may have been part of countless entities before you. We are threads in the cosmic tapestry, continuous with the whole. And when we speak of children of stardust, we mean all of us, not just humans, but every form of life. The ancient oak tree in the forest is your cosmic sibling, forged from the same ancestral matter. The eagle soaring high above, the dolphin playing in the waves, the microbes in the soil, all are our relatives in the grand cosmic family tree of matter. We all sparkle with the legacy of long-gone stars. It's humbling, but also elevating, to think that we carry such a heritage inside us. It can change how we view our lives. Our personal story didn't begin the day we were born, or even with human history. It began with bright stars, billions of years ago. Our story stretches back to the very beginning of the cosmos. In each of us, there is a piece of the first light of creation, and a piece of the brilliant fire of ancient suns. We are time travelers of a sort, containing in our bodies pieces of the cosmos's history. This knowledge also gives new meaning to the cycle of life and death. When a living thing dies, its physical substance breaks down and returns to the earth, and eventually those atoms may journey outward to become part of new formations. Nothing is truly lost. The atoms simply get recycled in the great cosmic ecosystem. Perhaps, one day in the far future, some of the particles that were once part of us will become part of a new star, or a new world, or even new living beings in some distant time. In that sense, we are immortal, not as the individuals we know, but as part of the eternal flow of matter through the universe. Ashes to ashes, dust to dust, the saying goes. And that dust is stardust, destined perhaps to shine again in some new form. Knowing that we are made of star stuff can inspire a profound reverence for the cosmos that birthed us. Ancient cultures often felt a deep kinship between human life and the heavens, even without knowing the science. They looked at the stars and felt that those lights had something to do with them, that their own stories were connected to the sky. In a way, they intuited a truth. Our existence and the stars' existence are intertwined. Today, science provides the details that underscore that intuition. We have learned that our fates truly are tied to the stars, not in the sense of astrology's fortunes, but in the physical sense that no stars means no us. This realization can also affect how we look forward to our future as a species. We have come from the stars, and one day we may return to them in our travels. When we build starships or send probes into the galaxy, it is essentially the universe exploring itself, star matter reaching out to star matter. If we ever find life elsewhere, we will likely discover that it shares the same building blocks we do, the same cosmic origin story. Any extraterrestrial beings we might meet would also be children of stardust, just raised in different stellar nurseries. That would make them our kin as well, distant cousins in this vast universe. Under the light of our sun, a star which generously shares its energy with us, we grow and live every day. It is easy to forget this connection in the rush of daily life. But now and then, when you see sunlight filtering through leaves, or watch the stars emerge at dusk, it's worth remembering. That light is part of you, and you are part of it. The photons warming your skin on a summer day embarked on their journey from the sun's core 8 minutes ago. But the atoms in your skin have journeyed across cosmic time and space to be where they are. We stand in a sunbeam, but we also carry the glow of long-dead stars within us. As children of stardust, we have the privilege, and perhaps the responsibility, to appreciate the cosmos with open hearts and minds. We carry within us a piece of the universe's history, and with our unique ability to reflect and wonder, we give the universe a way to appreciate itself. This union of matter and consciousness is one of the most marvelous outcomes of cosmic evolution. The cosmos has become aware of itself through our eyes and our thoughts. The universe spent billions of years in the dark, without any witness to its splendors. Now, through us and perhaps other beings, it can witness and contemplate its own existence. Standing on a beach at night and looking up at the hazy band of the Milky Way, one might feel small. But consider that the very material of your body was there when those stars formed. You belong to that panorama. You are the cosmos, in human form, marveling at itself. In that sense, there is no reason to feel insignificant. Yes, we are small in size compared to a galaxy, but we are large in meaning, carrying inside us the story of the stars themselves. We are rare and precious, as unique as the circumstances that formed us, and yet completely at home in the universe, because we are made of the universe. And so, learning about our stardust origins gives us perspective and peace. It reminds us that even when we feel isolated or insignificant, we are part of something vast and magnificent. We are the products of exploding stars and cosmic nebulae, of the silent, patient churn of the galaxy over billions of years. Our lineage is truly cosmic. With this understanding, we circle back to the mysteries that remain before us. For all we have learned about our origins and about the workings of the heavens, many questions still float unanswered, like stars yet to rise. We stand on the cosmic shore with a handful of insights, while the great ocean of truth lies undiscovered before us. This realization that there is so much more to know and experience leads us into a final reflection, one of endless mysteries and eternal wonder. It is the perfect mindset with which to conclude our journey. Endless mysteries, eternal wonder. Our journey among the stars has illuminated so much, yet it also reminds us of how much remains in shadow. We find ourselves at the edge of an ocean of unknowns. For every question we answer, a dozen new ones seem to emerge, sparkling like stars on the horizon of our understanding. This is, in its own way, a gift. The mysteries that remain ensure that our sense of wonder will never end. Think of all that we still do not know. We gaze out into the night sky and see billions of galaxies, yet we wonder what lies beyond the limits of our sight. Is our universe just one of countless others, an island in a vast archipelago of universes? We do not yet know. We detect an invisible something tugging on galaxies. We call it dark matter, for lack of a better term, and we puzzle over what it might be, since it neither shines nor speaks to us except through gravity. We feel the universe expanding faster and faster, driven by an enigmatic force we've named dark energy. But this too is merely a placeholder for a deeper truth that eludes us. These grand mysteries loom large, inviting our curiosity. What is the nature of reality at its most fundamental level? How did everything begin? And what will be the ultimate fate of all that exists? We have hints and hypotheses, but no final answers. We ponder the origins of life itself. How did inert matter on a young Earth spark and kindle into living cells? Perhaps one day we'll recreate that spark in a laboratory or find clear evidence in ancient rocks. But for now, it remains one of nature's most exquisite secrets. We wonder about consciousness. How is it that the stardust of our brains gives rise to awareness, to the experience of colour and love and memory? How does the mind emerge from matter? Here, too, we stand in awe of a mystery right at the centre of our being. There are also mysteries of scale that confound us. We have journeyed outward to the cosmic and inward to the subatomic, and at both extremes, our understanding is challenged. On the smallest scales, when we peer into the heart of matter, we find the bizarre realm of quantum physics, a world where particles can be waves, where they seem to wink in and out of existence and influence each other across distances in ways that defy common sense. Why does the quantum world behave so differently from the world we experience? We strive to understand, but for now, it's as if nature speaks a secret language at that level, one we're still deciphering. And out in space, the fabric of space-time itself can twist into strange shapes. Consider black holes, born from the collapse of massive stars. They hold gravity so intense that not even light can escape their grip. Inside them, all our familiar physics breaks down. Space and time themselves might swap roles or cease to have meaning. What lies at the heart of a black hole? A singular point of infinite density? A tunnel to another universe? We simply don't know. It's a question that challenges the boundary of our understanding and reminds us how much further there is to go. Yet rather than disheartening us, these unsolved mysteries are sources of inspiration. They are the cosmos whispering to us. There is more to discover. They beckon us like distant lights in the dark, challenging us to continue the quest. The history of our species shows this pattern. We solve one riddle and uncover another. We climb one mountain and find many taller peaks beyond. With each mystery uncovered, we have grown, not just in knowledge, but in imagination and in humility. It's worth reflecting on how far our curiosity has brought us. We began as wanderers who told stories about the lights in the sky. Now we have sent robotic emissaries to other planets, touched the outskirts of our solar system, and detected the faint echo of the Big Bang, a whisper from the dawn of time itself. Each achievement would have seemed like magic to our distant ancestors. And yet, with each answer gained, new questions have opened like doors to rooms we never knew existed. We learned that Earth is not the center of the universe, and that raised the question of what, then, is out there in the vastness. We found planets around other stars, and now we ask if any of them bear life. We discovered that the universe is expanding, and now we wonder whether it will expand forever, or if something will one day halt or reverse it. Our progress is defined by this interplay of knowing and not knowing. What's truly beautiful is that the more we learn, the more we realize how much remains to be learned. Instead of diminishing our wonder, each discovery has only magnified it. The universe did not lose its magic when we understood that stars are fiery furnaces of nuclear fusion, or that rainbows are the refraction of sunlight through raindrops. If anything, knowing these truths makes the reality more profound. And beyond the truths we have uncovered lie further layers of reality, still veiled, each promising to deepen our awe. Mystery, in a sense, is the lifeblood of wonder. If everything were known, our minds would have no further heights to ascend, no new marvels to chase. But the cosmos is generous in this regard. It is vast and rich enough to ensure we will never run out of questions. There will always be a new why, or how, or what if to ponder. Each generation inherits the wonders uncovered by the last, and then finds its own new puzzles to explore. The universe, it seems, will never be a finished story. It's an endless unfolding, inviting us to turn page after page. It's also possible, of course, that some mysteries will remain mysteries, not just for our lifetime, but for all time. There may be limits to what our species, or any species, can know, either because of physical constraints or the boundaries of cognitive ability. But rather than causing frustration, this too can be a source of solace. We can find peace in the fact that there are realities larger and deeper than ourselves. The unknown isn't just an absence of answers. It has a presence of its own, a grandeur that we can feel even if we can't fully understand it. It means that the universe will always have an element of the mysterious, something that transcends us, inviting a kind of reverent acceptance. As we come to the end of our cosmic contemplation, we find not a conclusion, but a gentle openness. We have journeyed from the possibility of life among the stars, through the quiet loneliness of the cosmic night, past the distant future where starlight fades, and finally to the realization that we carry the cosmos within us. And we conclude with the understanding that much more awaits beyond the horizon of our knowledge. This open-endedness is a beautiful thing. It means the story is not over. The story of the universe, and our story along with it, continues on and on. Perhaps, as we finally lie back and gaze one last time at the starry sky in our mind's eye, we can do so with a sense of serenity and gratitude. The universe is vast and mysterious, but we have the privilege of being a part of it. We get to experience its wonder, to ask questions and seek answers, and to simply marvel at it. Not everything will yield its secrets easily, and that's all right. Some mysteries we can cradle like cherished keepsakes, knowing that they will inspire generations to come, even if they are never fully solved. In the end, the cosmos may keep many of its secrets, yet it has shared enough with us to ignite an eternal flame of curiosity. We find joy not only in the answers we have obtained, but in the very act of wondering. There is a calm delight in standing before the vast unknown and feeling its depth without needing to conquer it completely. There is something gentle and profoundly human in acknowledging, I do not understand all of this, but it is beautiful, and I will keep exploring. So, as our long voyage through space and thought draws to a close, we carry with us that peaceful, slightly mysterious feeling that the night sky so often brings. We carry the knowledge that we are connected to the stars above, and the humility that comes from recognizing how much we still don't know. Above all, we carry wonder, that enduring, childlike awe that makes us feel both small and infinitely connected to everything. Under the endless sky, with the hush of the cosmos around us, we know that our questions are as vast as the universe, and our sense of wonder as eternal as the stars. And that is a comforting thought. No matter what the future holds, there will always be more to learn, more to feel, more to marvel at. The story of the cosmos is far from over. In fact, it may have no end. And we, the curious children of stardust, will always be there to listen to its silence, to ask our questions, and to gaze in amazement, now and forever. We close our eyes, minds at ease, and hearts full of wonder, content to be a part of this great and mysterious universe.